Good morning, everyone. So we will be starting today's technical sessions. Let me introduce our first speaker for today, Dr. Kunal Abhishek sir. Dr. Kunal Abhishek sir, Scientist E and Head of the Department, Cybersecurity and Forensics at C-DAC Patna, has been actively engaged as Principal Investigator of many R&D projects, building next-generation cybersecurity solutions for the government fraternity, including strategic sectors. Prior to joining C-DAC Patna, he has served as Scientist and Group Head, Network Security Research Group at Society for Electronic Transactions and Security, SETS, Chennai, and as an R&D engineer for nearly 7 years in the Weapons and Electronic Systems Engineering Establishment, WESI, where he had been responsible for the development of indigenous elliptic curve-based software solutions for the Indian Navy. Dr. Kunal sir, as an expert committee member, was instrumental in the amendment of the Information Technology Act 2000 of India with the introduction of Digital Signature N-Entity Rules 2015. His research interests include cryptography, ransomware and its countermeasures, secure kernel development, formal verification of software systems, statistics, and software engineering. He also serves as a reviewer of publications in popular journals from IEEE Systems, Springer, Elsevier, IEEE International Conferences, etc. He holds a PhD degree in computer science from the Bharatidasan University, Trichy. Sir, I kindly request you to please come on stage. I request Hariharan K, Scientist C at C-DAC Patna, to kindly welcome Dr. Kunal sir. So please hold the dais and lighten our speaker session.
Good morning to all of you. This is my first session here, and I thought to have the theme of the symposium as Security Engineering for Trusted Cyberspace, which is actually the theme of the symposium. I thought that it is only 20 minutes session, so I will be covering a few things which is required to make a cyberspace safe and trusted. So my talking points will be as follows. I will be just having a kind of introduction to the cyberspace, and we will see the warfare techniques, how it has been done in the past. Then trusted security, what does it mean by the trusted security? After that, we will see how a trusted security can be achieved. Following that, we will have the security engine for trusted software system, and to understand it better, we will take an example of microkernel development, which is popularly known as SCL4, which is claimed to be a formally verified microkernel. Since the time is very low and it is not sufficient for me to go in at length, but what I will do, I will just give you the brief overview And presentation I made in such a way that whatever I have kept in the box, that is the main takeaway from this session. And the colors, especially I used to make it attractive. And the magenta color, basically I have highlighted something which needs to be taken care of. So these all talking points will be actually constituting to understand the requirements of the trusted cyberspace and security engineering practices that we need to have it. So let us start with the cyberspace. What does it mean and what exactly it is? Everybody must be understanding that cyberspace is just our internet, but it is not so. It has all the networks, including the internet, which can be controlled and have a command on it. So cyberspace is only, we can say that some system is not in cyberspace when it is not connected at all. Now, when it is interconnected, there is a severe security threats also, and actors are also there. So the borderless nature of the cyberspace is seen as a national security as of now. There is a statement that I have made here that cyber war happens at the speed of light. It is not my statement, it is a famous book, Cyber War, you can just refer it. They say that when cyber war happens, there will be no time for a decision maker, crisis decision maker to react on it, because once the attack is happened, it has done all the damages to you. So it is very important that you should have the trusted space before in hand. So what are the tactics a nation use for the cyber warfare? You must understand that all nations are already preparing for the cyber war, and Ukraine-Russia conflict is the main example of that, recent examples you can say. So everybody is intruding in the other nation network and infrastructures, and they silently put trapdoor and logic bombs, and that too in the peacetime, when you don't expect that it is happening. But since my senior colleague from Navy is also there, he is more into it, dealing with it. He is also yesterday saying that yeah, it is true. And this is true. So what does the logic bomb and all do? It has been just kept in your software application by somebody, it may be a cyber warrior or it may be a cyber criminal. And on the right time, they will just trigger it. Their motive is to shut down this your computer system or server and give the DDoS kind of attack you will be having, or erase all the data. Second is what we know as trapdoor, which is nothing but a Trojan horse. So their interest is to steal the information on the right time. So these are all software which are software piece of code which have unauthorized entry in your system. So what exactly we have seen in the past decades, after 1972 I am saying, and this I will say why this year is very crucial for us to know. Whenever cyber criminal or cyber warrior, they write anything, they will just put some trapdoor inside, and that will be with a purpose that whenever they want it, they will just have the access quickly and they can do their job. There is one typical example for this kind of attack, like computer copier program. Its job is just to copy something. So the kind of the copier program designer, they have written a simple code and the computer will be copying something. But the cyber criminals or cyber warriors can use it as a weapon. How they will do it? They will inject some piece of code and they will make it to be triggered on a certain time. And when the right time comes, this code gets activated and it will do something else than copy the program or some text or some video, whatever. So the designer, from the designer perspective, they have never wrote this software piece that it will be used as a weapon. But it has happened like that. So what does it mean here? It means that when the copier program designer, they have not had the rigid and clear specifications. So this is the point you have to note for making a cyberspace or cyber or a program safer in the cyberspace, you need to have a rigid and clear specifications. These specifications, generally which you leave out, it will not be attended by the developer, but it will be quite important for the attackers, and they will attend it and they will use that thing against you. Now we come to the trusted security. So why I told 1972 is important, because Anderson was a scientist who has given the definition of reference monitor. Reference monitor is something which you may not be knowing, but it is the backbone of all your operating systems and all other crucial programs. What it does, Anderson in those times, he has told that the reference monitor should be implemented, whose job is to validate all the references. And what these references will be pointing to are the programs, data, peripherals, etc. And made by the programs in execution against those users. It may be users or other programs also. So I am saying that subject. The reference monitor is not only responsible for assuring the references are authorized to access, but what kind of access rights they have got, like read, write also. This was made in action in 1972 itself. Now, we will go in this direction further. A combination of hardware, software and firmware that implements reference monitor is called the reference validation mechanism. So note down that this reference validation mechanism is the backbone or the principle of formal verification also in the later age. Okay, so Anderson reports has added 3 guiding principles. So all the trusted system has these 3 principles in hand, maybe extra and maybe not in public. That is the point. So the first thing, it should be a tamper-proof. So your OS or whatever program you are writing, which is critical, it should be tamper-proof. It should not be, integrity should not be violated. That means whatever designer has given you, you should not violate it, so that the accountability of the malfunctioning of that function goes with the developer. Second, it must be always invoked. You cannot say that program is not working. When I am taking an example of operating system, because this is the first piece of software that is always running. You cannot do any work without that. So that example, that case study I have taken here, considered here. So it must be invoked. So OS will be always running. Or similarly, any other program will be always running. And third, it should be comprehensive. What does it mean, comprehensive? Means that anytime if we want to test it or examine it, it should be there. And we can say that, yeah, it is functioning correct. This is called formal verification. So the initial definition of formal verification, initial introduction rather, has come in 1972 itself. But now, after 2010, it became a mandatory criteria, and all the critical software components are needed to be formally verified. Now the trust. So this is what I have given you, the background of why trusted security is important, and how it can be achieved from a technical point of view, like this report, what I have talked about recently, just now. So I'm giving you some examples of what happened in the previous time. In 2020, there was a report that VPN apps caught stealing users' data secretly. Then around 2 years back, the VPNs were found to be tackling and recording the locations and all. If I remember correctly, last year our Minister of States, Mr. Chandrasekhar, has quoted that VPN vendors should reveal the data to the government, otherwise they cannot practice in India. So this was the connecting sequences. Okay. So now, how you can assure the trusted security? There are many methods, not only the formal verification. Formal verification you have to apply when software you need for your software to work as per its job specification correctly. That means what? First you have to specify the jobs correctly, and the software has to act as per that. Second thing is how to implement this formal verification for on any point of time at some piece of code. It is very difficult actually. It's a three-step systems where you have to write the abstract specification first, and then refinement, and then its implementation. This is a three-step. Writing an abstract is really difficult. What it says, suppose you have a SRS, it is called Software Requirement Specifications. It is a very technical document. It is not, it is a concluded one that this exact requirement we want. If you give the SRS, so forward verifier, what his job is to see the English statement, what you want, make it in such a way that it can create a mathematical objects of that. These objects are connected or dependent. So in English, I am saying dependent. In the technical form, I am saying connected. So these are connected. So their dependency has to be removed. There should not be any kind of duplicacy in the system and all. So you will feel that you have given a long English statements. You can say it's pseudo codes, probably. That it is a 3-4 pages or 1 kilobyte of the program code. And then when you write this abstract specification, it will just shrink to 20-30 KB. Or it will be very less, 10 times lesser, shorter than the actual size. So why does it happen? Because of the only single reason that you have made it in such an atomic way that there is no duplicacy exists in the system. And connections is very clear. So for the students out here, I will say that graph theory is very important for you. It has a lot of optimization solutions in the cybersecurity as well. So for cybersecurity, you need to have a mathematics, a statistics, then very good knowledge of programming as well. That comes third, and then experimental experience. Those things, if you have, then you can understand the topics much better. Then the second thing is, whenever you write, whenever you have planned that I have to be not only secure but trusted, you need to go with your own products or your own solutions. Why? There are three motives behind it. There should be a transparency in the security, because whatever you are claiming, you know that yes, this is what I have made inside. But in the foreign vendors, you cannot say that until you verify it thoroughly. So I am just making a strike on the open source based development community, that these are not written by you. Please have a thorough investigation of the code before you take it into your any critical application. Second thing is administration to control. So you must have administration of that program code, that whatever way you want to tweak it, you can tweak, but others can't. This is more important. And of course, we are here and we need some money savings also. So these are the three core factors why we are going for indigenization. Like that, there are many methods also to make our cyberspace trusted. The other one is a zero trust architecture. Why it is very crucial nowadays? Because the systems have moved to the microservices, not a single service. It will have a microservices. So they have got very small chunks of atomic tasks, and these are called, if you can search out, these are Berkeley filters. They are using the kernel programs, and they are too fast, and microservices are implemented through those. So what happens when microservices you are implementing, you are getting the speed, as well as it comes with a trade-off, that how you are making it secure. So all your things, I don't think the firewall and all the peripheral security measures or things like that is capable of capturing all the services, microservices and all. So you need something called zero trust architecture. So in the implementation part itself, you have to architect it in such a way that you should not trust anything without verifying it. The moment I say it has to be verified and then trust, you are going in a latency of some extra work or operations. That means you need computation, higher computation. So it comes with a cost. So you have to have this cost, but it is required. Security cannot be taken on grant. It may not be at its best, but at the acceptable criteria. At least that threshold we have to meet. Other systems are military-grade systems. Commodore Mohammed sir is there. Actually, he has deployed this in the Navy. I was also there in the team. This is called the data diode systems. So it is a kind of unidirectional flow. So if you have a critical kind of military-grade solution you want for a critical network architecture, you have to place data diode very objectively. So this is what one of the measures that you can have in the trusted secure zone. You have to implement such network topologies and apparatus like this. Then there are many solutions are there existing. One by one, you can see it. I have not listed out all. 4 or 5 I have listed over here. Now I am coming back to the security engineering of trusted software system. So what does it actually demand? So you cannot make everything very trusted. I mean, I am saying that within 1 year or 2 years. It will take decades to make everything in line of the security practices and the controlling criteria and the standards and all. What you need to do, you take some critical component, get it formally verified, use the microservices architecture, make it JTA deployments, and keep it in your control. So this is the way you can have a trusted solution, and you can say that the space where you are functioning is trusted. I am taking the example of SEL4 microkernel, which is claimed to be the first formally verified microkernel by NICTA group. It has been in association with the Australian kind of defense agency. So they have come up 10 years back on this. So I am giving you some principle that they have done and they have made in their kernel, which I am correlating with my session, and where you will be understanding that how trusted security is very much important and how these guys are playing with it. So they are safeguarding their own space. So we need to go at least following them with some of our standards and techniques. So what I have recently shown in the diagram, this is just that diagram only. You can see they have formally verified the kernel. Kernel is around 9,000 lines of code they have written. They have formally verified it. In that 9,000 lines of code, not the full. A part of the kernel space they have done it, formal verification. Then the micro architecture they have used, services architecture, and it is of course made by them from scratch. So this is, they can say that I can trust that kernel. But I am here, I will not say that it is trusted, because the last green layer is not green for me. It is green for them. So let us have a look on the SEL4 microkernel. This is a third generation microkernel of L4 series. Your Linux is also a L4 based system only. Claimed to be the first microkernel formally verified. And the code was written as 8,700 lines of code and 600 lines of assemblers. In that 300 lines of code is the processor code. And it has the feature abstraction of virtual address space, threads, inter-process communication fast path, and capabilities for authorization. Now, I have already told that abstraction is the main tough work. So here you can see the features, what we are stating here are the abstractions. What does it mean? That when they implemented it, it was, converted into or transformed into the mathematical objects. Okay, and that is the beauty. They got 13 PhD students, PhD clearance on that project, and still 50s are, minimum 50 are there doing it. So it is not the easy job. Among all, the inter-process communication handling is the most tedious work, to my experience. So now, machine-checked formal verification of SEL4. So the focus of them was to guarantee that SEL4 microkernel is free from the programming errors. And they have provided a mathematical proof for that. And that kernel is consistent with this specification. But they have told in public, just quote it in public, that assumptions are the correctness of compiler, boot code, assembly code, and management of cache hardware. Yesterday night I was with the Balaji sir, who is the next speaker, I think after 10:30 or so. We have a chat, and where he told that compilers are also malfunctioned and given. So that's why I told it is written in the public, don't believe. Okay, but to pass an exam, it is important. You say that these are the, we believe that this will not malfunction. So the approach, what they have used in the SEL4 development was the high-level specifications to the C implementation. As I earlier stated that there is a three-phase formal verification technique. First is the abstract, then is the refinement, and third is the C semantics implementation. Refinement is nothing which is sitting in the middle of this thing. That is just taking care of the kind of communication between the abstraction to the C implementation. So this kind of interface. So the mathematical thing has to come in the machine language. That is the duty of this refinement. If from a developer point of view, if you tell me to formally verify something, I will say that the maximum time I will take in the abstract specifications, then lesser time in that middle layer, and the third layer will be much easy because it is just the implementation of C semantics. So that any programmer can do who is good at C. So I just give you a brief, this is a very big subject. So I have taken main things in a single word. I will say at least one statement for each of them. So check SEL4 kernel design. So when you have to formally verify a machine, I mean the kernel, through machine check verification, check their design. Check functional correctness proof of kernel C implementation. Then your IPC. Then binary of the kernel implements correct C, that you have to give the proof for that. Proof may be mathematical or anything. Generally we say mathematical because mathematics is the easiest tool to prove your statements without costing anything. If you have to go for an experiment, you can't do it so easily because experimental setup is too costly. So mathematics is the only easy way and that you can do it and you can put up your imagination or interpretation in front of others and they will believe you. There is a sort of verification they can do on the mathematics but not on your experimentation so easily. So experimentation showing is easy but conducting is difficult. So produce proof for correct access control enforcement, proof for information flow non-interference and the worst case execution time analysis. This paper has got IEEE transaction based paper thing because worst case execution time was you are detailing the kernel at very minute level. That was not a cup of job for everyone. No one can do it so easily. So this paper has got that award. And then an automatic initializer for the user level system that connects kernel level access control enforcement without reasoning about the system behavior. So these are the steps for formal verification. Each step is a big work in itself. I will conclude with this slide because time is 20 minutes. Then finally comes to the kernel design. So you must understand from a kernel writing perspective that the kernel should have highly interdependent subsystems. That means kernel has certain memory occupation and that is directly dealing with the hardware. There is no such mechanism involved that if your kernel gets corrupt that it will be saved or it will be auto recovery mode, something it will come. It will not. And it is very fast because it is directly accessing the buses and all. So what happens if you have interdependent subsystems, if any component gets faulty, your entire kernel will be shut down. So SEL4 uses a technique called compartmentalization, where they have beautifully designed kernel in such a way that it cannot be, the one component cannot hamper other. It will give you some time, and that time that they have also predicted mathematically. So that's why they are saying that in real time my kernel won't misbehave. Okay, so worst case thing, the WCET analysis was that only. So the goal is to minimize complexity of the kernel modules. So for kernel developers, the suggestion is you must use code which has simple statements because it will do the job without any complexity. So with this, I will conclude my session here. Thank you. Any question?
highly sensitive military networks. So sir, my question is how it has helped the entire defense system to achieve a safe communication, if you can throw more light on it.
See, what is the requirement of such systems in place? That is the main question, an answer for that your question. You don't want anything which is coming back, or suppose your system you want it has to be isolated, and I can only give some pass some data to it, and nobody can do it. It should be a single point-to-point connected through the wire. Okay. In that way, you have made it isolated one in a controlled way that it has to go through the wire. It may be wireless also now, but there are security prevention mechanisms are there. Okay. So you just push the data and you be free. Now you are very sure that you don't have anything which you can extract from that server, because to see the connected ones, I just say that your Cat6 cable will have RX and TX, two types of transmission wire inside it. If you can open it, you can see. So the receiving wire will be there and TH will be chopped off. So there is no possibility that it will come back. Okay, this is the case when this is used by a wire. But now the system has not like that. It has come with the optical fiber and all. You cannot do just like that. But there are still other things are also there. This is a military grade solution. I may not be able to more explore it to you. You have to ask, and probably Mohammad Kare sir is the chief architect of that during my time. He may be able to. I have told whatever is there in the literature. Okay. So I think I have answered. Yeah. Next question. Yeah, I said.
Thank you for this nice informative session. So Dr. So I'm just wondering, I mean, this is a case study that you have highlighted. That's really interesting. So I'm just wondering that have they used any existing formal techniques, or they have come up with their own formal abstractions, refinement, all this?
Yeah, for formal techniques per se, I have not used so far, but I was at the point of doing it. Okay, but what I did it with the SCL4 is I could make it compatible with the x86 architecture, and it was made for only ARM. But what happened in that, when I did the x86 architecture based this thing in my previous employment in SETS, my colleagues are here from SETS also, I tried to load up application on it to check it. It was a cube application. My hard disk got damaged, and 3 successive damages I left it. So this is my experience, but with other experiences I could understand that how formal verification technique is now important to us, and it should be there. At least we cannot do to all our critical software components, but at least 50 lines of code, 100 lines of code, like your smart contract or blockchain. It can be formally verified. It will take around 6 months time with 10 of the mathematicians and people, but it should be. That's my recommendation. As you are working in the blockchain, I previously know you from the institute, so I'm saying this.
Thank you. Thank you.
Thank you. Any other query? Yes, sir.
Hi, morning. I'm Mohammed Surinder. So you talked about the various subsystems which are there inside the kernel, and they are highly interdependent, or there's a lot of dependency on them. So in this formal verification of model checking, is there any way to find out all the possible race conditions which can happen? And very soon this will explode into too many too many parts of the tree. So what sort of formal verification is appropriate here? Some sort of bounded model checking or something of that sort?
Sorry, the point was very good. Boundary checking and all is one part. There are many things you can do it. Not all for everything. We have got theorem provers. We have got type-safe programming implementation. So now new methodology is you implement the kernel in the type-safe language Rust. Suppose this is the statement. This gives you some specification related clearance that okay, it will work in a proper way. Boundary checking is something which you want your system not to misbehave in the exceptional cases. I have to write a sum of 2 integers and then you have given supplied complex numbers. So boundary checking is very much important here. So it is case to case basis. There are many other methods. It is not only that mathematical proof you have to give. So like inter-process communication fast path. How do you see that? There are buses which is using it directly. How you can say that wires or your circuits, I am saying it wires, it will be formally verified. It is not like that. But there are something called known answer test in the software community. You know, for testing, you know that if I supply this input, output will be this only. And now you are putting the input-output checklist in place and seeing whether it is deviating with that or not. If it is deviating and you know the answer is known, you say that yes, it is failing under certain conditions. Now you have to write the specification in such a way that such abnormality should not happen. So in this way, this is a continuous process. You have to do it. But at some point of time, you will get that the whole program code is now verified in some way. So at that point of time, you will say that yes, I have completed everything. Even the SEL for what I have just shown here as an example, they have also told that we have not done the compiler and some other thing. I have only worked on the TCB, trusted computing base. That is okay, they are saying, but as a Indian, strategic actors, we cannot say that yes, we are believing you. But they are saying that. So it is in that way. So once you started it, it is a continuous process. After some point of time, you can understand that yes, my system, now it will not misbehave. If any extraordinary condition comes, then also you have some exceptional handling mechanism. That is self-healing immediately, time restrictions for certain job. Many things are there that we can do. So we can take it in the offline session also, sir. Thank you. Any other question? Yes.
Good morning, sir. I am Shivam Shekhar from Andhra College of Engineering. I am a first year student in the Department of Computer Engineering. Sir, you mentioned that earlier in 2020 you had mentioned about the taking of data through VPN, sir. You also mentioned that
VPN.
Yeah. And you also mentioned that our government minister Chandrasekhar mentioned that VPN should share the data with government to operate in our country. So, according to you, what should be the fine line of transparency while using VPN? Because most of the time we use to hide our privacy.
So this is the problem statement. What you have asked, it was asked many years before. Fortunately, we have Dr. Saxena here, who was the chairman of that committee. The governing committee as well as checking the PRSG. And I was the principal, PI for that project. So the problem statement was like this, only what you said. The thing is, we have our VPN software which we have taken from some vendor. Okay. So what they are claiming that you can put it in your mobile phone. Suppose in the mobile phone I am saying, and your IP will not be visible. Those things they will commit. Okay. But your data to that VPN devices, I am saying software devices, is going plain to them. Okay, they are just saying that, ensuring that from your mobile to the ISP to the next destination, it will be encrypted, or the tunnel will be established. What before that? So the government is asking, it should not be in your control. The data, when the user uses it, it should be under government control. So whenever you are giving VPN services, this first part at the instance, at my side, source side, you have to share it with government. You don't share with the private fellows or some non-state actor, I can say. But this you share with us. So VPN company is saying, no, I will not do that. So the minister has told that you have to do, otherwise you cannot practice. Right?
Thank you, sir.
Thank you.
Thank you, sir. I request Commodore S. Mohammed Kale, sir, to kindly present a token of gratitude to Dr. Kunal, sir.
Sir, it's my first boss in my job.
It is indeed encouraging to see that a lot of questions are coming from the audience, and I hope that this would continue for the other sessions as well. So we will be having a short tea break, and all the honorable members are requested to kindly take your seats by 10:05 a.m. Thank you. All the members are please requested to kindly proceed for tea and kindly assemble back by 10:05
had a
a.m.
long walk and we discussed.
Hello, hello, chick, hello, 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 chick. Hello, chick, hello. Hello, chick, hello, hello, chick, hello, 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 chick, hello, hello. Hello.
thing I have seen from my time. Electronic city. Balaji asked me to just say hello. I do not know. They are so much in detail. Where are you staying? It's comfortable. Why are you feeling in this library? It's a historical place. Okay, ma'am. My name is Jitendra.
Then you will understand what kind of
While working. That's great. It's a nice shot. Think that you have
Welcome back. Let me introduce our next speaker, Dr. Anupam Chattopadhyay sir, Associate Professor in Singapore. Dr. Anupam Chattopadhyay sir, Associate Professor at...
Yeah. I think you're on mute. Yeah, okay. Yeah. Good to see you. Yes, please.
Let me introduce you to our next speaker, Dr. Anupam Chattopadhyay sir, Associate Professor NTU Singapore. Dr. Anupam Chattopadhyay sir, Associate Professor at NTU, began his tenure as a faculty member in September 2014. He received his BE degree from Jadavpur University, India, MSc from Alari, Switzerland, and PhD from RWTH Aachen, Germany, for which he received the Borges plaque for outstanding doctoral dissertation. He has worked as a member of consulting staff in Coware R&D, India, and led the MPSOC Architectures Research Group in RWTH Aachen, Germany, as a junior professor before joining NTU. He held visiting positions at Politecnico di Torino, Italy, EPFL, Switzerland, Technion, Israel, and Indian Statistical Institute, Kolkata in the past. Dr. Chattopadhyay sir currently heads a team of 20+ researchers overseeing projects in the area of computer architectures, security, design automation, and emerging technologies. His research advances have been reported in more than 100 conference journal papers, ACM, IEEE Springer, multiple research monographs and edited books, CRC Springer, and open access forums. He also regularly serves in the TP series of top conferences, reviews, journal conference articles, and presented multiple invited seminars, tutorials in prestigious venues. Sir, we are humbled by your presence. Over to you, sir.
Okay. So shall I start now?
Yes, sir, can you start?
Okay, so thank you for your kind introduction and inviting me to speak in this forum. it was very short notice, that's why I could not make it in person, but I will be glad to interact with you following this presentation as well. So I would like to talk today about quantum safe digital world using post-quantum cryptography, or in short PQC. So this is a very relevant topic in the current scenario, and I will just present a perspective limited by the time constraint on what we are doing on this area. So the first thing that many of you are probably already aware of, that there is a big threat of an attacker having access to quantum computers for public key cryptography. So this has been a study done in 2019, but these numbers are steadily improving. What we definitely know is that if we have access to large enough quantum computer with a few million of qubits, then within a few hours, you can hear me clearly, right? Okay, so then within a few hours, it would be possible to break the RSA and ECC, which are the foundational public key or asymmetric key crypto systems used by all security protocols that we are accessing right now. So one question that many people do ask is, what is the possibility to have this many qubits in near term? And this there has been some debates on that side, but in general the consensus is that we will definitely see within a decade, given the current rate of growth, because big corporations like IBM, Google, they are heavily investing on scaling up their current quantum technologies. So already we have quantum computers with more than 1,000 qubits, and besides the number of qubits which are required to break RSA and ECC, this number can also reduce depending on better quantum error correcting codes, or depending on better algorithm or some improvement over the specific source algorithm. So these improvements on error correcting codes and the attack algorithms are being reported on a regular basis. So that is definitely a very practical threat that we are looking into. Besides this, there is another kind of issue that we have to keep in mind is whatever data that we are storing or encrypting right now, they have a long shelf life, and we are storing the data using a system that has also a long life cycle. So if we are buying a hardware security module or a server now, then we can expect it to be running for 10 years or more. On the other hand, if we are just looking into the data, there are data from the insurance, public sector, or even life sciences that have to be stored in a system for more than 20, 30 years, which is mandated by different organizations, that if you are collecting data on environmental degradation or healthcare, which might help improving the quality of medicines in the future, then you must store it for 20, 30 years. Which means that there are malicious attackers who can collect the data that is being stored now using current crypto systems, and they can decrypt that data. If it is sensitive data, some data related with the regulations or defense, this kind of data, they can decrypt it later when the quantum computer becomes available. This is the kind of threat that we talk about, the harvest now, decrypt later threat. So which means we should be starting with the migration to a quantum safe security environment as soon as possible. And this is already happening, which we call as the migration to post-quantum cryptography. There are multiple countries and standardization bodies and corporate industry players who have announced their plans on how to do the migration. There are different such attempts are being reported, like NATO is trying a quantum secure virtual private network in 2022. SoftBank is trying how to integrate PQC in 4G or 5G network. Diplomatic messages are being encrypted using quantum cryptography in France. So this kind of news are being reported also on regular basis, which means that there is a growing consensus and effort to secure our current data in communication or data in storage to a quantum safe environment. Now, when it comes to the quantum computing and quantum safe environment, there are lots of players actually, the companies which belongs to the domain of purely quantum computing. Companies like Google, IonQ, Xanadu, they are building bigger and bigger quantum computers which can serve many different industries including quantum machine learning or quantum chemistry. It need not only apply to security, but of course many of these machines are posing a threat to break the crypto system. In order to protect against that, we do have two kinds of solutions. One that comes from the post-quantum cryptography or post-quantum security, and it can come from quantum key distribution. So even at NTU in Singapore, we are working to launch a spin-off around post-quantum cryptography, which we call the PQ station. There are other companies like Sandbox AQ in US or PQ Shield in UK. They are offering different solutions around post-quantum cryptography. Similarly, there are efforts by companies to build a dedicated infrastructure or a network with optical fiber that can perform quantum key distribution. So one of the big questions that many people do have is, how do I protect against quantum computing attack? Shall I use PQC? Shall I use QKD? And to discuss on this debate, so there is a very simple tabular comparison that I put here. Like for the case of QKD, we definitely have to move to a new infrastructure where we have to create an optical fiber cable with photon generator and receptor. It has some limits in terms of the coverage with the distance. And beyond this limit, if someone needs to transmit messages, they need classically authenticated repeater nodes. The only thing that security object QKD can ensure is the key exchange, that means the confidentiality between the sending and receiving parties. Whereas if we want to do something like hashing, integrity, non-repudiation, then there is no specific offer from QKD. The standardization of QKD happened recently with a couple of organizations offering QKD standards. On the other hand, PQC standardization happened over Europe and US, multiple organizations in IST, which actually ran the PQC standardization competition. So the direct application that we see from the quantum network with QKD is key distribution, sensing, random number generation, whereas PQC is much more comprehensive, that it can cover any security requirement we need. So if I want to move faster from the current generation to the quantum safe environment, then the PQC is a complete solution. Whereas if you look into even commercial QKD offering, the thing that they are proposing is say QKD as an additional layer of security on top of post-quantum cryptography. So they need post-quantum cryptography because there are restrictions on the infrastructural development that we have right now. So if we want to simply sign a document from my laptop or from my smartphone, then I can't expect it to happen over a QKD link. It has to happen on a traditional telecom infrastructure, which can be completely supported with post-quantum cryptography. So this is the basic argument on both camps that we have been doing. So one of the big challenges that one needs to face is how to do the migration itself. And in PQC migration, this is the journey that we began in 1994, when Peter showed that quantum computers can get security. NIST initiated the PQC standardization process in 2017. And in last year, in 2022, they announced the first PQC standards. Subsequently, it was also adopted, and in the White House in the US, they launched a specific memo saying that one needs to migrate to quantum safe environment in near future. So we do expect that we will enter into post-quantum era in 2030 onwards, and this will take us some time to migrate current crypto systems and security protocols to PQC. So this is where we started our research, and we are following this journey right now. So one of the most important things that we did in our PQC study is to look into the side channel analysis. Because if you look into the classical security protocols, they typically have a simple encryption, decryption with Alice and Bob, with Eve as the malicious adversary trying to do something about the message being transmitted in a public channel. But what we know is that a realistic model for cryptanalysis should also take into account various side channel emanations, which can be in form of heat, visible light, it could be from the faulty outputs because someone is able to inject a fault. So this is the realistic side channel attack model that we took into account when evaluating the post-quantum crypto candidates. And we do have a very sophisticated setup at our lab, including some of the boards that we custom designed in order to get the best signal-to-noise ratio, so we can perform collection of electromagnetic waves, or we can also perform injection of high voltage or short pulses in order to create a fault injection attack. So these are the setup that we have used in order to do the side channel attack and fault injection attack analysis of the post-quantum crypto candidates. We did a lot of corresponding research publication, which you can find in the paper that I am listing here. It's not possible in the short time span to go through each of them, but the main idea is that we looked into lattice-based cryptography, which is one of the prime sources for multiple candidates in post-quantum crypto standard. We looked into their physical attacks, including side channel attack, fault injection attack, including hardware trojans and backdoors. We did some survey, and we also did efficient implementations of the post-quantum crypto candidates in software and hardware. In software, for example, efficient implementation on embedded platforms like ARM, Neon optimization, or server-scale platforms like GPU implementation with CUDA extensions, as well as optimizations in hardware like FPGA and ASIC benchmarking. So we try to also integrate these implementations into practical scenarios, like if I want to look into the secure boot flow of any modern processor, they do have a digital signature embedded in multiple stages of the bootloader, which start from the 0 stage and moves on all the way to the user level application. So we integrated two post-quantum crypto candidates, XMSS, which is a standard in Europe, and Ethereum, to study on RISC-V and ARM processors, and we also analyze what would be the overhead if we migrate to post-quantum secure boot for processors. So this is one study that we did. So what we do bring on the table is we have been working as academic researchers with multiple studies in PQC. We also took active part in NIST standardization process by presenting our result to NIST standardization forums, as well as influencing the development of some algorithms in this process. We do have very efficient hardware and software IP for different PQC finalists and standard entries. We also integrated that into secure protocol testbed. For example, if one likes to integrate the post-quantum crypto in automotive security, then what would be the server and client study? We did that over Ethernet and CAN network communication, reported our studies in some research papers. We do have some embedded device prototypes for side channel and fault injection attack testing, which is done eventually with security evaluation. That is an essential step for common criteria of security certification. So to summarize, we have been working on post-quantum cryptography, which we believe will be an essential component in quantum safe digital world. This is already standardized to NIST. Other standardization bodies also participate in this, like BSI in Germany, ISO across the world. We did very comprehensive study on efficient optimization, implementation, and side channel attack results. We do believe that hardware now directly related threat is becoming very practical right now. So people should talk about how to migrate to PQC environment real soon. So this brings us to the challenge of planning the quantum migration and how to explore the synergy with additional security protocols and quantum key distribution. So there might be some argument from the QKD camp telling that the PQC might be subjected to some kind of unknown attack in future. So many people, they try to put the eggs in multiple baskets, and they will say that we want to have a hybrid network by having a QKD with classical telecom infrastructure. In such cases, we need to build a real application, that's what we are working on now, to show how QKD and PQC can coexist. So this is our setup and some early results. And of course, I missed the trip to Rajgir this time, but I could remember from our history lessons that they had an ancient wall, which is nearly 2,500 years old, to repel attackers. So this is bringing us again to this discussion on how we can create a quantum safe network to defend against various kinds of cybersecurity attacks. So with this, I would like to conclude my talk. I would be happy to discuss on academic or commercial research around this topic with you in the future. Thank you very much.
We can take up any questions, if any, for Dr. Anupam sir. Yeah, can you mic?
Hello. My name is Jitendra Kumar. I am working in C-DAC Bangalore as scientist C. Actually, we also recently started working in this particular domain. And I would like to ask you a question regarding this crypto token. How long it will take industries to come up with the crypto token, which includes this post-quantum cryptography?
Can you please help me repeat the question because the voice was not very clear?
Yeah, actually, I want to know what is the status of crypto token. Have you worked in the crypto token, the small device which is used for digital signature?
Yeah. So what we have done here is mostly the PQC basis studies on the classical infrastructure, and when it comes to the quantum cryptography, or if some people refer to the QKD, then we do believe that QKD offers this uniqueness in terms of physics-based security. So they say, okay, we can transfer the keys from one end to the other end, but QKD has its own challenges. It cannot scale over longer distances. One needs to also take into account the noise that will be there definitely in any kind of transmission. So if I want to transmit, for example, an encrypted data across a QKD link, then what is the guarantee that it will be perfect error corrected when I am receiving at the end? There are also side channel attacks that people have reported on commercial QKD photon generator nanoreceptors. So this kind of study has to be done very thoroughly before we accept QKD as a perfect solution. But what is definitely known is if I look into near term, that if I want to start transition into a quantum safe world, then within next few years, we cannot expect to have a long-range communication just using QKD, which means we are always limited by the range. And if I am introducing any repeater node, the repeater node has to be classically authenticated. So I have to have some kind of trust in the repeater node. So this is precisely the reason why very recently European Union and NSA from US, they have released a couple of position papers clearly stating that they don't see QKD to be a near-term solution for the quantum safety. It's only for some niche applications. Let's say you are trying to communicate within a premises, within an office space, or within a few buildings in a setup, then you can go ahead with that, but not beyond it.
And one more question, which are the algorithm you have used in your experiment? Like crystal, fiber, or dilithium, something?
So we are actually in talks with the QKD companies which are working in Singapore and QKD companies based in India. We are also in touch with academic researchers who are working on quantum key distribution. So we see that there is a room for an integrated and hybrid network to get the best of both worlds. But if I want to transition tomorrow, I don't see QKD coming to picture because if I give a very simple argument that I want to sign a digital document from my laptop, then I have to use some kind of public key signature. And unless my laptop has a quantum key distribution link with the server that's going to maintain the digital document after my signature, I can't find how QKD is going to do that. So it's a huge infrastructure migration challenge that has to be first solved.
Okay. Thanks.
Yeah. Thank you. Okay, I will be happy to take questions offline as well. I will stop sharing now and I look forward to the next speaker, Sashwat, I think.
Thank you, sir, for your insightful session.
Yeah.
I would like to introduce the next speaker, Commander Dr. Shashwat Raizada, sir, Director Cybersecurity, Mareli, Gurugram. Commander Dr. Shashwat Raizada, sir, is presently the Director Global Cybersecurity at Mareli Limited. A BTech graduate in electrical engineering, he holds an MTech degree in computer science from IIT Kanpur and obtained his PhD in computer science, focusing on cryptology from Indian Statistical Institute, Kolkata. Before joining Mareli, Dr. Raizada sir has worked in setting up the product cybersecurity department at Bosch Global Software Technologies Private Limited, targeting automotive cybersecurity. He has also built product security engineering fields for automotive from scratch with capacity and capability building in threat modeling, security concepts, key management, enterprise solutions, security testing, vulnerability management, cloud, etc. With cross-domain exposure, he has conceptualized and implemented complex projects, working closely with academia, industry, and government organizations. His expertise spans applied and theoretical cryptography, automotive cybersecurity standards, having worked for several international automotive OEMs, and is a subject matter expert in the ITS panel of the Bureau of Indian Standards. Over to you, sir. So it appears here.
Yeah, good morning. I hope you can see my screen and you can hear me. Super. So, well, to begin with, I would thank Anupam for taking us into the world of photons and telling us what is coming in from there. And I have an enormous task of getting you from the speed of light to the speed of our Indian roads. And the topic that I'm bringing out is experience sharing of cybersecurity implementation in the automotive domain. That means I'm going to speak about cars and cybersecurity over here, which I'm quite sure several of you would be surprised as to what is cybersecurity in the automotive domain. So I would actually give you first what is the necessity of this, followed by bring out what are the complexities that we face, and then tell you how we are doing it over here across the globe, and finally question and answers. So this topic is actually quite an extensive topic. It would even take over a day to speak on it, but I have condensed it into a short 10-15 minutes capsule, and based after that we could actually go on for Q&A. Okay. So if you look at this car, I would say this is the most well-protected car from hackers because it's got nothing in it, right? So this would be, being the most secure car, it has got the minimal functionalities that are possible. However, today our cars are terrifically networked. Okay, there are external networks. For those of you who would have picked up any car right now, say even in the Indian market like an XUV 700, you would be given an array of features like, you can open the car using your mobile, you can switch on the AC 10 minutes before entering. There are, a lot of OEM connected services that they keep on looking into a car if anything is going wrong. You can connect the car to third party. You can order things like Zomato on your dashboard. The car is connected to the transportation system as such. So you can see that the modern car is connected across the net. And whenever there is a connection, there is a attack vector. So attack vector typically is the path which an attacker takes to reach its target. So connecting cars to the external network, unlike the ancient cars, although got lots and lots of features, but also gave an avenue of hacking it. And today we have IoT search engines like Shodan, which can actually pinpoint where a car is on the map. So, whilst we are getting lots and lots of new features, the risks also have increased from a cybersecurity perspective. If you look inside the car, you can see that the car has now become, a host of electronic control units which are communicating to each other on an internal network, which is typically a CAN or controller area network. Also things like linear network, FlexWays, and Ethernet is just coming up in it. So there are different components within a car that communicate with each other on these internal networks. Unfortunately, these networks were designed without cybersecurity, and now they have become the mainstay of the industry. So, whilst we are adding on to more features, we have got somewhat insecure networks inside, because when they were designed, we never expected that these networks would eventually be connected to the external network. So you can see from the previous slide and this slide, an attacker has a window of opportunity to get into your system through the external networks, piggyback into some access gateway and get into the internal networks, and from there he can do a lot of damage, which I will bring out in the subsequent slides. Also, we see a race up for autonomous driving. So in this slide, I can show you the way autonomous driving has been described. Level 0 is our traditional car, which I showed in the first slide, which is no automation. And this previously, this successively keeps on adding features like, lane keep, park assist, gets you level 2, partial automation at level 2 ADAS, to several notches of level 3 where generally Tesla is right now, and level 4 and level 5 is, you can send the car without a driver as such. So as we are racing up, more and more features are required, more and more sensors are required, and the dependency on the external environment increases. This adds up to the complexity. So whilst we are racing, what happens is cars are being hacked. Now, around 2010, people were speaking about it, nobody listened. But what happened in 2015 was, there were two hackers. What they did was, they got a journalist to buy a new Jeep Cherokee, and the moment the journalist bought it out, sitting remotely, using the infotainment system, the telemetry system, which is generally used to get the music and maps, they were able to hack into this car. They were able to disable the brakes, switch off the engine, they were able to change the climate control, HVAC settings, etc., etc. And this is the time people got alerted to this problem, and also the hackers also came. And since then, we have had an abundance of attacks, mainly through the telemetry system, sometimes through the TDM system, sometimes through Bluetooth, infotainment, etc., etc. And now it's actually almost every car has to protect itself from these hacks. Okay. We also have something like an electronic onboard diagnostics, which is basically for the good intention of knowing what is inside the health of the car, but it is being used for hacking as such. If you go to any conferences, you also have a car hacking village in some of the typical conferences like Black Hat, etc. So the cars now have started getting hacked, and considering the fact that consider the fact that there's human life involved in it, it's become a serious issue. So with this, I brought up the necessity of why we need cybersecurity, so that when you're sitting in your driving wheel, or when you're sitting in an autonomous car, you're not worried about that somebody can come and hack and put me down. So, but why is it so complex in the automotive domain, and how we've handled this complexity is the story that I am trying to bring. And this is something that can be translated into other domains also. Incidentally, in our country, automotives are the third largest contributors to the GDP. So automotive cybersecurity itself is very important. But complexity emerges from the fact that cars are the power user of software. In this slide, I show you the lines of code which are there in different objects, different things like from a space shuttle to all the way up to a modern high-end car. And typically we are handling about 100 million lines of code. This is continuously growing. We are having a move to software-driven vehicles. And we all know that there is a thumb rule: for every 1,000 lines of code, you can expect a bug. And hackers enjoy getting these kind of bugs from where they are able to enter into the system. So adding more and more code is coming into the car. When AI is coming, it is all adding it further, and the complexity keeps on increasing. Secondly, we have a huge supply chain. So if there is a car manufacturer per se, he will at most manufacture 15 to 20% of the components. The rest is through an ecosystem that is of suppliers who are giving different part of the components to the car manufacturer. And so we have to do cyber security across a huge supply chain. That means every company that is supplying a component, and in some cases there are multiple, they need to actually fit into the overall cybersecurity concept. The keys have to be set in, the crypto has to be agreed upon, and that's how we are able to, that's how the platform comes up. Okay? And third thing is that when we speak of keys outside the automotive domain, you just speak about keys for maybe 1 year, 2 year max. You know, that's what the CA will say. Don't be on 3 years, or the CA keys can be over 5 years. But I need to keep in keys in the car for over 30 years. This across multiple variants that keeps on coming. Okay? So you can imagine the complexity that keeps on adding in this particular domain. And there is no way, or the methods of changing the key and all are very cumbersome. It's just not practically feasible, because nobody would want to take his car to the garage just to change the crypto keys, etc., etc. Okay, so we have this complexity. Also, there is another issue of right to repair. Whilst I don't want the software inside any component, maybe the brakes or maybe the engine, to be changed, but then there is a right to repair issue also that is coming. That means if somebody's car has just got his flash memory has erased and it's just a software that glitch which is there, he should have the ability to burn in the code immediately. So he should have the right to repair. To repair, he needs a component, there is a software, the right to repair is required. But the moment this component is given off, there are several issues. Firstly, he may not use this, he may use some other variant. Secondly, this may lead to loss of intellectual property. So there are certain complexities involved in it, and right to repair is a burning issue in several countries, especially with the farm equipment people. Also, the automotive life cycle is such that it goes through different places, right from the time the vehicle is provisioned, to its shipment, to being given to you, and then if you make a resale, etc., etc. So you have to share the security credentials across different stakeholders. That makes things even more complicated. And finally, if all this was not there, there was the data protection people who have come in with the GDPR, and this is quite relevant because cars are also known as a third space. This is a place where you spend the most time after your home and office. So privacy issues are relevant over here, and we need to put in all those checks and balances also. So you can see that how complicated things are right now to handle this particular domain. Yet the automotive domain has come up with quite a robust strategy, which is kind of an example for others to follow. So we worked it out through standards and regulations, and these are the 4 major regulations that we have, and these regulations actually cover most of the use cases that we have, and it has been built in such a way that there is consensus across several geographic locations. Today, if you have to come up with one cybersecurity or one crypto policy within the country, there are a lot of people from the government service over here to know how big a headache it is. So imagine this is being followed by more than 54 countries. So that is a level of involvement that has gone. And there are 4 major standards that have come in, and I will dwell on each one of those. So there is something known as a UN Regulation 155. So this is mainly done by United Nations Economic Commission for Europe. So they have taken up this responsibility of ensuring that there is a uniformity in the way cars are worked upon or the standards. And the UNEC body has come up with 2 regulations, R155 and R156. These pertain to the way a car is made, manufactured, which also aligns with the ISO standard in it, which is called 21434. I'll describe this. So this says how the car is going to be made, what is the cybersecurity management system over there. The second regulation of 156 says, okay, you manufacture a car, but you got to support it for next 30 years or so. So how do you update the software and how do you update the credentials in a very well-defined manner? That is spelled out in Regulation 156. Plus, there is a product liability clause which is there in several countries, including ours. That means, if there is a certain standard product available in the market, I cannot sell any product which is of substandard to what is there in the market. So, if I do that, that is negligence, and there is a product liability clause, and it is very much applicable to cybersecurity. So, I cannot sell a car which doesn't have the correct cybersecurity involved in it. And to all these things that are there is an audit process which is given by an ISO standard, which is the last one over there, ISO PAS 5112. So under this framework, for the last 7 to 8 years, we have started shifting our development and production and deployment of cars. Now I'll dwell on each one of those. So ISO 21434, it gives us a cybersecurity management process by which we do the entire development, conceptualization, development and production for car. And this works out in a V cycle. So this standard tells us how the cybersecurity policies and processes are supposed to be done, how do we manage the risk, how do we foster a cybersecurity culture. The process that is followed is the car manufacturer identifies certain critical ECUs, and for each of these ECUs, we go through a well-structured process of firstly identifying what the threats are using a process known as threat modeling. So this is the beginning of the product life cycle. Then once we have identified what are the threats, we see how we can counter those threats by defining some security goals. And once we have done that, we come up with some security requirements and security concepts. That means what is going to be implemented where. We scale it up to how it is going to be implemented at the end of line during the manufacturing. All those security requirements are put in. Once these requirements are built into the overall requirements, we have a process of integration and verification and doing external pen tests. So this entire sequence has been built up into an automotive life cycle development process, and that's defined by the standard 21434, and it is implemented using a regulation known as R155. Okay, so these are very, very sound practices that have come in, and based on this, every car manufacturer or supplier follows these guidelines, and this in turn ensures that we have built-in security in mind. And then once this is done, we move on to the next step, which is the software update management. Now the car has actually been sent out, it's in the field, and we want to change the software in it. So then there is a well-defined process of accounting for each of the software updates which is there. There is a specified way of telling what is the different configuration releases, which is called a pattern known as RX software regulation software identifier, also known as RX Win. So it means that we have a unique identifier for each software update, and for each car we keep a track of what is the level of software over there. So if there is any vulnerable software, we can immediately put an alert to the car user and tell him that it's time for you to update the software if the auto update is not available. This brings in strict accountability, and of course we do take care that the vehicle is in a safe state and a secure state whenever the software is being updated. So as a result of this, you can see that whenever there's a bug, etc., or anything performance enhancement is done, it can be done actually without you having to take your car to the garage, and which is a good money saver for the automotive domain also. So it's avoiding recall. Once we have these standards in place, there is another standard which is being followed for auditing the cybersecurity management system, whether we are doing it properly. So this brings up the entire audit program as such, and the methodology is of course based on another ISO, but tuned to the automotive domain. So that's ISO PAS 5112. Once these things are done, the entire ecosystem for creating a car is in place, but there needs to be some kind of a legal approval. So this is done by every country having its approval authority, and for every model the standard process right now is the car manufacturer takes the model to the approval authority, who in turn checks all the aspects, and now cybersecurity has become an aspect in it. So the approval authority starts checking whether things are made as per the ISO standards, those artifacts are there, it reviews it, and then only it lets the car out and it gives an approval that the car can be sold in that location. So this is the method that has been followed over here, and the industry in a very collaborative manner has adapted it, especially in locations like Europe, Japan, etc. So this is the process we follow over here, and now the final shot over here is, if you can see, automotive world is very serious. Porsche, which manufactures this car called Macan, the EV version of this costs about 1.65 crores in India. So it had a very long life, but now it is said that we are going to discontinue with this model because we are not able to meet the cybersecurity requirements. So that is the level of seriousness that our domain works with. So that's about all from my side, and I'll be very happy to address the questions.
We can take up questions for Dr. Rajavan, sir. Any questions? Yeah.
Yeah, I have one small question, Sir.
Yeah.
Yeah, just a very high level question. If I try to roll out a new car with all the security objectives met, how long does it take to get it audited to the standardization process and everything? What's the timeline?
Okay. If everything is, there are two parts of it. Developing it in a standardized manner. So typically the development takes about 3 to 4 years. So as we speak, I am working on models that are going to be rolled out in 2027, 2028. So 3 to 4 years is the development time. And once it's developed, it goes to vehicle type approval authority. The first one takes roughly 2 to 3 months for going through all the processes if you are in order, if everything is in order. And subsequently, the same can be used for other countries, which process is called a homologation process. So then you have a, then the next part is quite smooth.
Okay. And just on a follow-up question, if the standards are not properly met, then you give some examples of taking rollback, or someone may be imposed a fine or something. Are there instances already in India where such things have happened due to cybersecurity malpractices? Something was called back or fine was imposed in automotive?
So in the Indian context, people have, authorities have taken a very cautious approach, because getting into regulations directly and imposing it on the industry may be counterproductive. So they are waiting for the standard, rather they had waited for the standards to be readily available and implemented in Europe. And now the Indian versions of the standards are coming in, which is called AIS 189 and 190. So we are having identical standards. So we haven't reached that level yet where we can say that, okay, this law was not followed, but yeah, once the standard is in place, then we'll have more such cases that are coming out.
Okay, right. Thank you.
Thanks.
Thank you, Surajada. This is Saxena from DRDO. Long time we met. Just one query here. is there a continuous process of BAPT for your cars by the companies even after the cars are in use and they have been sold? Continuous kind of testing, penetrative testing on whether the softwares, because first hand approval is all right, but subsequently, so that company from its own can recall the car's particular model if something is found out. So is there any fixed time frame mechanism that every year we will do BAPT and then do a reassessment?
Yeah, I think that's a very good question. There is a mandate that we have to follow. It is called continuous monitoring. So when we say continuous monitoring, it means having a kind of a digital twin of the car available with us and continuously checking on if there are any vulnerabilities that have been reported on any of the software or hardware that is used in the car. So the response times to that also are very high and stringent. If we see that there is a vulnerability within 24 hours, we are supposed to report it if that vulnerability has impacted. If it is likely to impact, we have a longer lead time. It's about a week or so. So moment we see any news in the or any indicators in the NVD directories, that is the vulnerability database directories, we are able to immediately do, alarms comes out in our system in the vulnerability management platform that we have. It's part of the digital twin of the car, and we are supposed to do an analysis of that vulnerability. Does it impact us? If it's a high impact, then we have something known as an incident response team that comes up, and we immediately start working on a bug fix for that. So this is definitely there. The next level that is going to happen is there are going to be vehicle SOCs, it's called VSOCs. So like you have Security Operations Center for your enterprise networks, for vehicles you are going to have vehicle SOC where real-time data would be exchanged with certain cars who are owners of whom are willing to do it, and in real time we will be able to get that okay, is the car being about to be hacked or not. So all those alerts and alarms will actually start coming from the fleet. So that's the longer vision. Right now we are there very stable with the digital twin methodology where we have got an identical replica of the car with us in our system.
Thank you very much.
Do we have any more questions? Yes, we have one more question. Myself also.
Incidentally, I'm sorry that I was not able to make it because of certain compulsions, but there we have Commodore Gombatkare, who is there in the audience and who is also an expert in this field. So any follow-up questions, if you want to, or you want to have any discussions face to face, I think he's also he's a good person to speak to in this. And of course, also with Anupam, his secure boot using post-quantum is something that had really excited me because secure boot is a major component of my security architecture.
Okay, sir, this is Ashok Bandhupadhyay. I am from C-DAC, Kolkata. This is a wonderful talk. Regarding this automatic process, what in terms of the security aspects, what you have said, there is a possibility of data leakage. In that, the data protection concept is already been implemented into the system, or is there any provision coming up in future?
I didn't get you. Can you just repeat the question?
Yeah, basically the data, because the automatic cars what we have seen is now connected everywhere. Anybody can be connected to anywhere, right? So in that respect, the data leakage possibilities are there. And in that respect, I think the data protection norms or the regulations has to be implemented. Is it already there, or something is coming up?
Okay. So again, another excellent question. The question is that a car is generating lots and lots of data, So what are the data protection mechanisms that are there? So there are the issue has been sorted out in two folds. Firstly, when we look inside the car's network, which is internal to the car, there for me confidentiality is not of much relevant because it is alerts and alarms that are going on or some tasks that have to be performed using certain keywords. So there we actually implement MAC, which is message authentication. I'm not worried about the secrecy of it. I'm worried about the authenticity. So for example, if there is a command that goes to the brakes, I want that the command is authentically from the source where it is. Nobody should be able to inject these commands into the internal network and put it. So authenticity and integrity is very important for me there, and we are following a feature known as secure onboard communication, which only deals with integrity and authenticity. Right? So it's internal vehicle data, and these are just very quick info that is going on, and that's it. When I look to the external world, there we need to use encryption, and then there are certain challenges that have been put into the external network that there is only a specified number of IP addresses that a car can communicate to. So then we have to run proxy services on those IP addresses to infuse the multiplier over there. So there things like SSL are being used because 4G and 5G is giving you very good bandwidth. So their confidentiality also we get, we can integrity also, we can do authenticity also, so that's pretty cool over there. But inside the car, the timings are very stringent, we can't afford to encrypt and decrypt, so we're just resolving it with integrity and authenticity.
Actually, just the outside the car, what you said, that mechanism is already inbuilt, that so that there is no question of any data leakage or something like that. Somebody cannot access any sort of information from that particular car. That is already some standards are there, or something is coming up.
So every OEM what it does is, every car manufacturer what it does is, depending on the use cases and services that he is going to be providing, he sets up this security overlay. So depending on the type of services that are being provided, the encryption etc. is built up, and this is kind of industry standard protocols are used, but the way it is implemented is very proprietary to the OEMs as such.
Okay.
So if I look at Ford, they say that okay, you use SSL, but they have something known, an additional encryption system on it known as SIMP. So this, every OEM builds it up, uses something which is industry standard, tweaked to his particular use case.
Okay. Thank you.
Thank you, Commander Dr. Raizada sir, for your insightful session.
Thank you so much. Missed being there, just like Anupam said. But next time maybe.
Moving on. We are privileged to have with us Commodore S. Bombarkere sir, Senior Director Secure Things, Pune. Commodore S. Bombarkere sir, an electrical engineering graduate from IIT Madras, joined the Indian Navy's electrical branch in 1987. With a postgraduate degree in computer science from IIT Bombay, he actively contributed to academic and technology initiatives in software development and cybersecurity for over 25 years. Awarded the Nausena Medal in 1998, his 35-year naval career included pivotal roles at RESI Delhi, the software engineering group in Mumbai, and the naval technical group in Bangalore. Notably, he was a founding member of the Defense Cyber Agency. Serving on expert committees for information security, he also contributed to cyber education at IIT Delhi and holds an honorary adjunct fellowship at the National Maritime Foundation. Post-superannuation in 2022, he worked with Bosch Global Software Technologies for 2 years before assuming the role of Senior Director, Cybersecurity Consulting at Secure Things, Pune, focusing on automobile system cybersecurity, cybersecurity standards, process consulting, and threat and risk assessment. I request Shri V.K. Sharma sir, Scientist G and Director, C-DAC Mohali, to kindly welcome Commodore S. Bombarkere sir.
Good morning, everybody. Am I audible? We've had a lot of technical sessions yesterday where everybody spoke about extremely technical things, and technical things are the domain of young people. I was once technically competent, but now I would like to share a perspective that I have of security engineering, something that I built up over the last 25-30 years. There are certain basic principles of engineering which do not change. When we were taught software engineering 35-40 years ago, the basic principles are still the same today. It's only that you are using different technologies in a different environment. And therefore, it is important for us to see the perspective or the larger picture so that the work you do can have more meaning. And that brings me to a comparatively new concept of cyber resilience. Cyber resilience is, it's another term, it's another word, it's more English, but it has a certain significance that we must understand. Cyber resilience is driving the way we will implement or do cyber security engineering, and that's why I thought I would share that perspective with you. Traditionally, security engineering, at least from when I started it 20-25 years ago, was fundamentally it focused on implementation of security controls and processes. Security controls are primarily implemented in two domains, cryptography and network security. That is still true today. You don't do very much more as a security engineer. You restrict yourself to these two domains. You become experts in certain parts of it. And at some point in time, there will be slightly more senior or experienced people who will integrate it into a bigger picture. And therefore, there was a fair amount of system awareness that the fact that you can't do these in isolation, you need to integrate them, you need to look at a larger picture. And that finally evolved over time to come to a niche standard 800, which is a very old standard, which all of us are aware of. And that defined certain ways in which we need to go about, say, security engineering. However, traditionally, security engineering had a technology approach. We worried about new technologies which came. We worried about the vulnerabilities that these new technologies posed. And we tried to use technology itself to try and plug these. We also tried to look ahead and we tried to see, okay, we need to worry about risk management. We need to worry about assessing the effectiveness of our security metrics. But still, somehow, it never looked at the whole thing as a system. By system, I don't mean the technology system, I mean the complete system which includes the organization and the human beings in it. Ours was, and still to a large extent is, a technology approach to security engineering. Which brings me to the concept of cyber resilience. We concentrated primarily on protection against attack as a cyber security engineer. But cyber resilience says you can protect yourself only so much against an attack. Attack is inevitable. You can do nothing about it. You can't even protect yourself completely against it, and therefore you have to be able to absorb the attack. You have to be resilient to that attack, which brings us to the word of resilience. And you have to be able to continue to perform despite being under attack and unable to protect yourself completely. That is how the concept of cyber resilience came, and it was sort of formally articulated in 2009 when the US Department of Homeland Services came up with a cyber resilience review, which was later on revised in 2014. It was followed in quick succession by two presidential directives of the US on critical infrastructure security and resilience, and the United States Cyber Incident Coordination Bill, which was passed. It finally came to a head in 2021 when NIST SP 800-160 was issued, which talked about developing cyber resilient systems, a system security engineering approach. This system security engineering approach covered a very large number of aspects which were not hitherto covered by security engineering processes as we knew them by the earlier NIST frameworks or other frameworks that existed. If you look at what is a cyber resilient system, this definition is to my mind the most beautiful definition for cyber resilience. It is there in NIST SP 800-160. He says you need to model a cyber resilient system on the human body. The human body is continuously under attack from a variety of things, whether it is pollution or germs or whatever. And you need to be able to continuously fight it. You need to be able to adapt and at least in the worst case, carry on a certain minimal level of functionality to survive and do what you are supposed to do. This effectively is cyber resilience, the ability to adapt and continue to work under cyber attack. So, the primary difference here is cyber resilience is a systems approach to security engineering. Now, a lot of you may say that, look, we have a systems approach in any case. We do look at the larger picture, right? But interestingly, even though we all claim to be looking at the larger picture, somehow it does not seem to translate into our day-to-day work. Our processes, which you look at organization-wide, whether it is the government, whether it is private industry, these processes are all still effectively in isolation. There is very little feedback and there is very little feed forward. And we tend to still work in isolation. A cybersecurity engineer does not work in concert with the safety engineer. He does not work in concert with the system developer even in many cases. In many cases, cybersecurity is an add-on, right? We have legacy systems and even new systems which are being developed have a very great resistance to the cybersecurity guy who comes because he is considered to be a pain, right? He only increases cost, he only talks language which nobody else understands and he is resisted. That is what is now being changed by this concept of cyber resilience and the development of a whole lot of new frameworks. But what actually makes a big difference is the Cyber Resilience Act, which is being enacted by the European Union. This is a legislation, or it's not yet a legislation, which is going to have very far-reaching impact on all of us, because other countries are also going to pass similar legislation. In fact, the previous talk by Shashwat, he brought out the fact that now the automobile industry has got liability for cybersecurity also, for cybersecurity or the lack of it in automobiles. And that is a consequence of this Cyber Resilience Act. UNECR 155 was passed as a precursor to the Cyber Resilience Act, and soon everybody is going to come under this, whether you're an automobile manufacturer, whether you're Microsoft who manufactures Windows, or whether you're any other company who manufactures any information technology or digital technology. The most important part of this is the third point, that cybersecurity has to be guaranteed by design and by default, and most importantly, it is now an OEM responsibility. Earlier we heard of this kind of OEM responsibility only in the case of, say, aircraft or automobiles. This is now going to also come into the software, into the IT industry. It's going to come in a very big way. It ensures end-to-end, you're worried about your supply chain, which is what Shashwat also pointed out. He says you have a large number of suppliers and they have to be part of your cyber system, your cybersecurity ecosystem. And most importantly, it mandates heavy penalty. Remember, he said you need 2 years to conform and 1 year to implement SIEM and VAVM, that's Vulnerability Assessment and Vulnerability Management. The point I have left out is the point which Shashwat made earlier. If you detect an incident on your SIEM You are mandated to report it within 24 hours. You are mandated to take action which is visible within 1 week. Right? These are timelines which are fairly well frozen. So it brings an enormous amount of pressure onto OEMs. And the only way you can do this is if you have a proper system in place. You need to have cyber resilience frameworks. So I'll give you a quick run through what a cyber resilience framework implies. These are some of the cyber resilience frameworks that have come by the US, the UK, which finally came out as the NIST SP 800-160, which I spoke about some time back. All these effectively talk about the same issues, management of assets, controls, basically looking at it enterprise-wide and system-wide. And the most visible framework which is actually implemented is UNEC R155 and ISO 21434, which Shashwat did speak about yesterday. I will give you a slightly different perspective of the same thing, though he did go into some details about what the standard contains. I will try and I'll try and give a slightly different picture about it. The important thing is UNEC R155 and ISO 21434 is arguably the first cyber resilience framework which is now statutorily to be complied with. There is no other framework. The NIST SP 800-160 is only a guideline. It is not a statutory compliance requirement. So now that the automobile industry has started it, the aircraft industry will follow, and soon, because of the Cyber Resilience Act of the EU, which is expected to be passed by the European Parliament in a couple of months, it will spread, and we need to be prepared for this as a community of cybersecurity engineers. If you look at the framework, this is the framework. Don't try and read all that stuff, but fundamentally, it consists of processes that you have to have in place at the organization level. Then there are processes which you need to have at the project level. By project level, I will take the case of an automobile. By project, I mean at a vehicle level. So if you have the same example, XUV700, XUV700 is a project. For every model of vehicle which you manufacture, you will have a project. For every project, you need to figure out these issues. Cybersecurity management, which is fundamentally your cybersecurity plan, your case, your cybersecurity assessment, which are all continuous processes. You need to worry about supplier management, which again Shashwat had brought out. You need to develop your cybersecurity concept after doing a threat and risk assessment. And you need to obviously thereafter derive cybersecurity specifications, integrate, validate, verify, and produce it in a secure environment. All these are cybersecurity processes as a part of design and production, which is done at project level. Now, once you have done it at project level, you produce it and you get a car. So you now have a product. A product is something which is tangible, it is physical, it is something which generates revenue for your company. So therefore, you need to have very fixed processes, cybersecurity processes for operation and management, and most importantly, cybersecurity monitoring, vulnerability analysis, and vulnerability management. Now, this seems fairly complete, but this is where the difference occurs when you come from cybersecurity traditionally to cyber resilience. In order to ensure cyber resilience, you need to feed back what you have done in your monitoring to your design, and you need to feed forward the results of your design to update your monitoring VA and VM. This is something which we know should be done but was never actually put in as a process, and this also includes update management, because when you want to increase functionality, you want to fix bugs, you want to patch what you have done, you have to have a very formal system of update management, which is defined by UNEC R156, and the guidelines are given in ISO 24089. It is important to understand that ISO 21434 and ISO 24089 are not they are not statutory requirements, they are guidelines to meet the statutory requirements of R155 and R156. It is very similar to the kind of guidelines which we got 20-25 years ago when ISO 12207 was issued for software development lifecycle. It's a very similar thing. There are no rules which are given, there are guidelines, there are processes, there is a description of what information you need to record and monitor. And you will find, if you study any of the maturity models like CMMI or there are some NIST maturity models also for cybersecurity, you will find all this falls very nicely in line with that. Now that I have sort of virtually I finished saying what I had to about cyber resilience and possibly how it will affect you, there are a couple of points that I wanted to talk about which relate to both what Kunal said and what Shashwat said. There are a couple of things that we need to think about. These are some popular beliefs or some ideas that we are being taught are correct. I personally disagree with most of them. One of them is to automate is to progress. That is what the industry tells you. That is what anybody with money tells you. And that's what seems to be a popular belief. I do not necessarily believe that to automate is to progress, because progress needs to be defined a little more philosophically. It is not only a matter of making things more easy, because there are two issues. One is the issue of design. In fact, there is a beautiful book. It is called The Design of Everyday Things by a man called Don Norman. That is a book I think every engineer should read, where he talks about the basic principles of design and the fact that if you want to design, let us say you want to design a device to communicate or make phone calls, then it should only communicate and make phone calls. You should not be able to make a cup of coffee with it. It may be more convenient. Why? Because you feel that every time I make a phone call, I want to drink coffee. So it does become more convenient, but it's a hell of a stupid design. It makes no engineering sense. And it is necessary for engineers to make it clear that when you engineer something, you don't just design for the sake of designing because you can. You engineer it for efficiency, you engineer it for functionality. And if you do not do that, then the point that Kunal brought up, formal verification. When you specify the requirements for any system, you need to specify them absolutely. Which means, as an engineer, when I design a system to that specification, I have to give you that functionality and that functionality alone. There should be no additional functionality, there should be no hidden functionality, and there should be no unintended functionality. In fact, these are the three things you hunt for when you do static and dynamic analysis of software. In the aircraft industry, this is very strictly followed, which is why you will find, even in warship design, this is very strictly followed, which is why you will find warships are very convenient places to be in. But they work and they are secure. And that is what we need to follow commercially as well, especially if the liability of cybersecurity now rests on you, either as an OEM or as a designer. The next is, progress needs advanced technology. That is something which I personally don't subscribe to at all. Progress needs appropriate technology. You do not use technology simply because it is advanced. You use advanced technology if it is appropriate, but you don't just use it because it is advanced. And that is something which we tend to do with AI. AI, when it started many years ago, was actually a solution in search of a problem. It was a large industry, a lot of money had been invested in it, and people went about, including the government went about, saying that we should have AI, use AI, use AI. And my organization was asked, AI. I said, look, I don't have any use for it. It may be a good tool, but I don't have any use for it. So that is a call which you need to make, and you use it only if it actually adds value. Because if it doesn't, it will only add complexity. And complexity is something which a security engineer does not like. The next thing is, there is a belief that vulnerability can always be plugged. While it may be true to some extent, the problem is the sentence should have said vulnerability can always be plugged in time. And that is the words which we cannot add. And unfortunately, this statement that vulnerability can always be plugged, technology hai, hum kar lenge, it does not work. Because you can never do it in time. You are always losing that race of time. And the last one is a debatable one. It is something which I put in, that the present economic model is good. What I mean by this is, the present economic model, it's not bad, but it's not good for me as a security engineer, because I am being forced to take a path where I use advanced technology simply because it exists, simply because so much money has been pumped into it and they need a return on that investment. That return can only happen if it is used. If it is used, you will buy it, they will make money. That's how the business goes, right? That is one thing you need to guard against. Are you using it because you are being subtly forced to do it, or are you doing it because you need to do it? The fundamental principles of good design remain. A good engineer, irrespective of whether he's a cybersecurity engineer, a civil engineer, electrical engineer, they remain the same. If you have a function to achieve, design to that function. Frills are not a part of good engineering. They may be a part of good architecture, they may be a part of good whatever. But to my mind, frills are not a part of good engineering. And therefore, I remember when I first studied software engineering in the early 80s, we were always told that you need to define an automation boundary. It is possible, in those days, of course, computers were fairly primitive. State-of-the-art PC, after I finished my MTech somewhere in the early 90s, was a 40 MB hard disk and I think 640K of RAM. So we were extremely resource constrained. So we had to worry about this. But in principle, given the fact that complexity increases, you need to decide how much you need to automate. The automation boundary definition is critical, which brings me to my last point, the part about complexity. Complexity is one of the primary causes of failures. And we can look at it in another way. If you have failures, it is most likely due to complexity. Now, there's a lovely book called Normal Accidents, Living with High-Risk Technologies, which was written by Charles Perrow. This was written, I think, in the early 80s, and it was based on the observations made by the author on the 3 Mile Island nuclear power plant accident. He came to the conclusion, the book is it's worth reading, but he came to the conclusion that complex systems, right, have 2 fundamental properties, you may say. One is they exhibit interactive complexity. That means there are so many components, and each of those components interacts with every other component in a complex way. It's a way so complex that you cannot actually model it, you cannot actually predict it, and therefore there is the element of unexpectedness. The next is, all these subsystems are tightly coupled, which fundamentally means that if I make a small change in one, you can have a very large change all over the countryside around it because of that tight coupling. And this actually implies that most complex systems are very, very sensitive to initial conditions. This is actually the basis of the theory of chaos, which came up when they were modeling weather, when they were analyzing weather modeling. And there's the famous story of, when a butterfly flapped its wings in Michigan, you had snow in Alaska, right? It is possible to actually figure out how that is doable, but the fact is, it is a complex system, and complex systems are inherently not modelable, because complex systems are non-linear. And the funny thing about a non-linear system is, you don't know anything about it. You know what is a linear system, and you know that a non-linear system is not linear, but you cannot say what it is. It's like I can tell you that I know what a banana is, this is a non-banana. I can't tell you what it is. So that is what you have to look at when you look at complex systems. And the biggest problem about complex systems is that as a consequence of the inherent complexity of the system, irrespective of the intent or skill of the designers, irrespective of the expertise of the operator, a complex system will fail, and it will fail regularly. Not because you had a very bad adversary, but because the system is complex, and therefore, and not only complex, that's the other part I wanted to bring you. See, I put one small thing called the logistic difference equation, right? The logistic difference equation is a very interesting equation. It was an equation which was used, it's an old equation, but it gained popularity in the early 70s when biologist Robert May, he used this to model the population, of fruit flies, right? And he found that when you have a population which has constrained resources, and that resource constraint is modeled by the variable R, depending on what value I give that value, the factor R, the population behaves in very different ways. It could increase up to a point and then oscillate and come to steady state. It could go up and then come down to zero, depending on what value I took for R. But what was interesting is, this equation is a difference equation in that every state now is dependent only on the state one before it. And that previous state is dependent on the one before that, and so on, up to the beginning of time, and it will be so on to the end of time. And therefore, if you look at each of these states slices in time as a subsystem, each of them is tightly coupled to each other, right? And they also interact with each other in a way which is not predictable. So though you have a beautiful equation, this equation can show tremendously unpredictable behavior for values of R between 3.1 and 3.3. Right? You can Google this. The logistic difference equation is a very, very interesting equation, but it gives you an idea of how something which looks deterministic is actually not deterministic simply by virtue of the complexity of the system. You are trying to model something which is non-linear with a deterministic equation. The equation is deterministic. You can use a computer to calculate it. But you are unable to predict how the population will vary for certain values of R. And that is the point I'm trying to make, that instead of focusing on security, maybe we should look at the problem in a different way, make it stand on its head, and focus on reducing complexity or solving the problem of complexity. And the bottom line is, keep it simple. Which brings me to my last slide, which is an engineer's creed. It is a creed, a belief that I have always had, I still have. That is, the best solutions are simple. If a solution is complex, it is most likely suboptimal and most likely wrong. And to add to that, as an engineer, it is your business. You are not a scientist, you are not a mathematician. You may be, like Kunal is a good mathematician, but he's also an engineer. If you cannot convey an idea simply, then most likely you have not understood it yourself. So I hope I have been able to convey this morning what I wanted to simply, because I do believe I have understood it, and I'm willing to take any questions.
Hello. Hi sir, I'm Divyanshu from C-DAC Northeast. Right. So I have a question mixed on both the previous session and this session. Right. So previously sir talked about digital twin, right? So and in let's say we want to develop a digital twin for military vehicles or defense vehicles, right? In that sense, what kind of standards we should look for, or what kind of, like, what exactly is the defense section looking for in a digital twin, right? Are they more interested in the vehicle performance, or it's like maintenance, or how, like, what exactly are we looking for, and what standards do we need to keep in mind? Like, sorry for the basic question, but
Okay, if I understand your question right, you're asking me whether we need to have standards for a digital twin. Digital twinning is a concept and it does not have any standards, unfortunately, or rather, it does not have any standards. It's not a concept of whether it is fortunate or unfortunate. The reason being, a digital twin is fundamentally a model. It's a mathematical model which you implement digitally so that in such a way that it mimics the behavior of the actual platform, right? If you remember, I don't know, as an electrical engineer, one of the first models or digital twins we made, right, was for an induction motor. You have a mathematical model of an induction motor. And when you do, I don't know how many of you are electrical engineers who have done this, when you are taught electrical machines, you are made to, you have a setup, it's called the Ward-Leonard setup for finding out the top speed characteristics of an induction motor. So you do that experiment, it takes 2.5 hours to do, and you get some beautiful curve. Then what you're supposed to do is you're supposed to model that induction motor, and on a computer with a program, generate the same top speed characteristics, and then you validate it and say, look, it works. Right? Your experiment was okay, assuming your model, which we take to be correct, is working. It's a very similar principle. You have a car, you want to model it so that I have a twin which is electronic, right? It's not a physical car. I can transport it. The advantage is I can transport it. And it should behave exactly the way the normal car behaves. But a digital twin needs to be specified for what it is that you are twinning it. Are you twinning it from the point of view of cybersecurity? Are you twinning it from the point of view of safety? Are you twinning it with point of view or from the point of view of performance of your braking system under different conditions? You want to simulate different conditions, right? Road conditions, and see, is my braking system working the way it is designed? So without actually putting a car through that test and destroying physical material, you can carry out tests. That is the primary aim of a digital twin. So you need to be clear what you are making this digital twin for. That is a user requirement which needs to come, and we can produce a digital twin for virtually any kind of functionality or testing you want. But normally, you will not have a digital twin of a car which is sort of a universal digital twin. It is far too large in scope and frankly a waste of time and money. So if you want to focus on a particular system like the braking system, or you want to check your climate control, or you want to check the function of the car under different conditions, many of which are adverse and may destroy the platform, then you tend to work on a digital twin.
Right. Then just a small follow-up here, right? So
Sorry to interrupt. So in the interest of time, can we take these questions offline? Thank you. Yeah. So C-DAC Patna is also working on a digital twin project. So maybe you can connect with us offline if you have any questions for us. I request Ms. Aarti Noor Ma'am, Scientist G, C-DAC Noida. Since she is not present, I request Shri Balaji Venkateshwar sir to kindly present a token of gratitude to Commodore S.N. Mohammed sir. Thank you, sir. Let me introduce our next speaker. Shri Balaji Venkateshwar sir is a cyber risk management expert and a passionate cybersecurity researcher with an immense experience in the field. Currently, he serves as cyber defense researcher and chief mentor at Cyber Vidyapeeth Foundation, Faridabad. Some of the other positions he has served include Chief Information Security Officer at BSE and IDFC First Bank, Director of Cyber Defense at Qualcomm, Executive Director, Cyber Defense at PwC, VP Cybersecurity at Bank of America, AVP and Head of IT Risk and Compliance at Wipro, and Manager IT Projects and Security at SBI. He has also served as member, chair and co-chair in various academic and government forums and committees. Shri Venkateshwar sir has also filed multiple patents in information security domain, published books, and leads a team of super specialists in cybersecurity to evangelize cybersecurity education in India's engineering institutions and help create a cyber army with 1 million strength for India in the next 5 years. Over to you, sir. I request Shri Ashok Bandyopadhyay sir, scientist at C-DAC Kolkata, to kindly welcome Shri Balaji Venkateshwar sir.
Namaskar. After long 3 deep engineering session, I am trying to touch on something which are far too critical for the country and far too important for the future. The future of cyber defense research and productization. Where we should start and where should we move in the next few years' time, next 5 years' time. As India is going to touch around 5 trillion economy in next 1.5 year time, the complexity of the cyber world is increasing much bigger pace with which our GDP is improving. So I'll try to cover it in my entire topic in 3 things, 3 steps. The agenda, the first is the incessant cyber attack. It is in the dimension of war. If you think that you are not in a cyber war today, then I think you need to go back and see the real statistics around it. CERT says that last year we have been hit and reported more than 2.9 million cyber incidents reported to cyber, CERT, which is almost double the number of last year. So if you think that 2.9 million attack has happened and reported to CERT, the number of report that has not happened to CERT will be at least 3 times. So in a day or in a minute, possibly 761 attacks are happening every day. So the second part will be, there is a sheer shortage of acute manpower. All university together in cyber defense with the basic education of cyber defense, missing out, the underlying cyber engineering components. The number of people produced across the country by 6,000 odd university is less than 3,000. The number needed today in India is 1.5 million, we don't have. And globally, Michael Page is the world's largest HR consulting company. They have got almost 3.5 million job offers available on the websites, but there is no taker for that. And the last one is that, Atmanirbhar Bharat, why it is far too critical in cyber dimensions. So I try to cover it up in the next 20-minute time and try to return back 20 minutes back to Kunal and team so that we can finish the agenda on time. Here is the list of the companies, It looks very enchanting. Most of the companies are American companies, the NATO companies, the companies from Europe. They are the company, those who left Russia 5th day of the attack on Ukraine. Just 5th day. 1,585 companies, including 865 technology companies, left Russia in lurch in just 5 days after the attack that happened on Ukraine on 28 February. Think about it, can you run your organization, your country, your office without Intel? Answer is affirmative no today. Can you run it without Microsoft? Can you run without Palo Alto or Juniper? The firewalls, can you run without McAfee? Possibly yes, we have some Indian products. But can you run without the basic underlying technologies? Ladies and gentlemen, the entire game dimension of geopolitics has changed completely. Now, technology companies are being utilized as strategic defense assets. Withdrawal of those companies happens overnight by simple message to those companies that you need to come out from there. And they join their country, their NATO interest overnight, and they try to weaken the enemies. Can India live without any one of them today? I know the answer is, none of you will disagree with me that we can't live without any one of them. The India which produces almost 5 million technology graduates, I won't say engineers, 5 million technology graduates including the BCAs, the MBAs, the MCAs, the BTECs, the BSc Computer Science. Many such graduates are produced. We can't boast of one big product in our hand. There is a need for soul searching. So Atmanirbhar Bharat is not a mere political slogan. It is for sustenance and survival. Most of the attack that is happening today is not by chance, they are all by design. 22nd February 2022, Prime Ministers in a closed door room meets Mr. Putin and signs on 39 agreements. Only 6 agreements have been published in the newspaper. 33 agreements remain top secret. That included an agreement which became later public 6 months after that signing of the agreement, that India agreed with Russia that they will buy their oils and their gases in a all cash deals, non-dollar deals. That is 22nd of February. 24th of February, Oil India Limited gets sacked. The most important company, those who are going to do the purification of your oil with 85% capacity to utilize and left was in lurch for 2 months' time. 4th of March, a small news outcome up. Jawaharlal Nehru Port Trust has been hacked. Are you aware about it? JNPT attacks on 3rd March. 1st of March, a news came that JNPT will be utilized for getting the oils in the dock. And 3rd March, they have been hacked just 2 days' time. I have been in the hacking side of the world. I know how it is difficult to hack systems of importance of oil and JNPT. It takes months of preparation, years of preparation. You need to sit tight, you need to know the enemies, you need to know their vulnerabilities, you need to have the access to those systems. It takes months and years, but it has been destroyed in just 2 days' time. So, our attackers are no longer just Chinese attackers or Pakistani attackers. Our attackers are even the NATOs. Whether we like this statement, whether our official statement of diplomatic concerns may be different from what I am speaking, but it doesn't matter. Fingerprints and the footprints of the attackers are so well clear that clearly suggests NATO is your 80% attacker today. And at a time when we are using components, every system, subsystems, and the compute systems coming from NATO, trusting them that they will perform when you are at war with them, I think it's like a great dream. And that makes the statement, Atmanirbhar Bharat is for sustainability and not just for mere sloganeering. This is the day for yesterday's report. India is the fifth largest or most targeted country on the earth. And actually, yesterday, Advocate Nami was showing that we were the fourth largest attack on DDoS. If you look into the, 2023, this is again a statement that has come from CERT. 761 cyber attack attempts happening per minute. 761 attempts are happening per minute in the country. And 529 government entity has been hacked. Government don't disclose it. We come to know only few of them in the newspaper. But unfortunately, the data which is lying scattered on the dark web, deep web and open web and the forums, hacker forums, clearly indicates 529 government entities has been hacked in the last 1 year time. 6,000 engineering colleges, universities, including all IITs. If any IITs are here, including the IIT Patna has been hacked. IIT has been hacked. And not just hacked. Most of the critical component of data came out of the public domain. As I speak today morning, there was a massive attempt on CSIR. And it's still continuing. Experimentation is still happening, they could not plug it off. The matter reported at 4 o'clock to 16 to SS Sharma. I sent a message that attack is on. And I continue seeing the experimentation is still happening. So we are in a very bad state. Whether they like it or whether they don't like it, we have to live with it for some time before we change the gear. And it is all state-sponsored attacks. There is no longer attack by the child, the hackers, the young boys and girls, no longer there. 278% increase in the attack. So what is the way forward? What is to be done? Rising cyber threats, absolutely sophisticated. Many times, a 0 day comes, a patch comes, your time to respond to those patches is 3 to 6 months time, and the exploit happens in next 5 days time. Whether we talk about DP world, the world's largest, shipping yard, port, the Australia, the patch has been released on 9 November, 11 November, the company has been hacked. They lost almost around $12 billion market. Everything is on technology. Without technology, we cannot live. And more technology. And that reason I said that I will not call them, we have produced 5 million engineers. Because engineers are the ones who create solution which last even if the sun does not last there. Because engineers are Brahmas, the Vishwakarmas. They don't create effects. We create the effect here. Cyber is a typical engineering problem and it requires real engineered solution. Unfortunately, the one who has written the operating system, they didn't know how to write the kernel properly. The one who has written the compiler, they have done the compiler incorrectly. And the bugs in the compilers led to the collapse of many of the systems. The person who has created the operating systems, to the systems, to the UEFI, to the BIOS, it has all been created by so-called engineers. And the bugs were there built in. Many times by design as a backdoor, many times by mistakes created the stupid engineers. And the time is come where product liability is just round the corner in every country. If you are selling your product to America, if your products are not good for third-party use, you might end up winding up your companies overnight. And the worst is that everything is moving to the cloud. I remember that getting a government data of a company was so difficult. My early days of my hacking career, I'm talking about 96 to 2004 time period. It was so difficult to get the vulnerability data. Today, you don't have to do anything. You have to go and find in cloud. I think 30,000 companies data was open in Jackma Cloud in Singapore. And trust me, those gaps will never be closed in the next 5 years' time. Because they have never been closed in the last 3 years. So another 5 years will continue with those bugs. Because there are some legacy systems that are not allowed patches to happen. And those will remain open. Earlier, the vulnerability assessment report used to be with the premise. Now it is lying on the cloud. This is the market size, the interesting market size here is 4 million people are required today. By 2030, we require 10 million cyber engineers. We produce just 3,000 cyber engineers a year. World need 10 million. And there is a very clear market size here, $424.97 billion market open for us. Right away, by 2030, it will almost develop to become 1 million cyber economy. So if you create a good product in cyberspace, a good engineer, the way you created in the 1990s, possibly you can see another internet, best economy in the country in the next 5 years' time. And that will change the year for the country. The dream of a trillion economy, I think 1 trillion economy can come from this market altogether. So what are the 3 things that we need to do if we want to take just 20% of the market share? And why I am saying 20%? 143 countries are part of the global south. And this global south, they need trustworthy compute systems. Compute systems which come from a country which they can rely upon. Trust me, in the last 5-year time, I have seen those 143 countries voting for India in every move whenever India finds an opportunity. The Vasudeva Kutumbakam, the world has really perpetrated very well. And if 143 countries can trust India, and I am very confident, the engineering capability, the C-DAC, and the NITI brings to the table, and the way they do the path-breaking research from TRL1 to TRL5 level, possibly the creation of a product and shipping it to the global south can lead to a huge change in the market opportunity. And to do this, we require 3 things. We say the cyber engineering, we definitely need to do in a very fast-track manner. We need to produce 1 to 2 lakh cyber engineers every year in the next 5 years' time. If you can't create a computer, can we create 1 million cyber engineer who leads the cyber engineering component across the globe? If 1 million people with $1 lakh salary can do the magic, it is almost around 40,000 crore, almost $6 billion, $7 billion market in the country. And cyber product is a key to success for indigenous as well as for global south use. And the last one is how to promote the market for that. What is to be done to achieve the target 100 billion cyber defense market. So 3 stages. Capacity building is definitely one of the most important components because without that nothing is going to be achieved. And that can happen from both sides. If you can have a good cyber engineering capability, possibly online, offline, I don't think it is possible to create 1 million in the next 5 years. It is mission impossible. And I have a suggestion on that, how to achieve that. And the second most important component is that how to set a cyber defense corridor, and I'm sure that NITI is putting the best foot forward under the available leadership of Mr. Sulika and the MMG work, Mr. Gunesh is doing on this space. Possibly we will see a lot of cyber defense corridor coming up in the next few years' time. And the third one is that how to promote the market. If you have the product, if you have the capability, how to take it forward and how to really become a force to reckon on the global marketplace. So let's see how we save the cyber education. Can we bridge the gap of 1.5 million resourcing gap in university today? The answer is absolutely no. If any one of you think yes, please raise your hand. I'll spend the rest of my years with you. Can we bridge the gap of 4.5 million by 2030? That's the requirement in India, around almost 10 million globally. Trust me, nobody else can create these type of things. You know, America has put in embargo that if you are a non-US and non-Indian, then you don't get a job in cybersecurity. Chinese people are not getting a job in cybersecurity in American market. Very clearly, and that's the reason, you know, many of the Indians are moving now in that space. And many of the American companies are opening the offshoot place in Ireland, where they are hiring only Indians. 38,000 cyber Indians has left in the last 8 months' time to Ireland. So, I believe this will be a $2 trillion economy by 2047. There is no reason to doubt it, because $1 trillion by 2030, another trillion by 2047. So, what is the best solution for that? We need to look for online cyber education as an option. But online cyber education is not what EDX, Coursera or Intel is doing. It has to be very different. It has to be a face in front of the machines every time. There has to be a simulator to do the practice and judge the performance of individuals. What Aditya's team has done on the labs, I love to have a look at that. But definitely require gamifications in the entire cyber education. And beyond the traditional, look, one thing that I find most of the syllabus that they are talking about hacking and CS certifications and ethical hacking. You don't require to become a cyber defense engineer, you don't need to be a hacker. You require to be engineer, I think, period, nothing more than that. You should know system engineering, you should know kernel, you should know Python programming, Golang programming, C programming very well. And then you need to know how to misuse those components. The best engineers are not the ones who know how to run the map to do the scanning of the system. The best cyber attackers are those who know how to make the map and finally customize the map for doing the scanning like Soda does. So, resource optimization, massive scale personalized education system, which can be very much possible by using some of the interesting study that has been carried out by NASA, which is known as 5E education. I don't know if you have heard about 5E model of education. No, it is worth having a look of it. 1967, Dr. P.K. Banerjee has written a paper on 5E education model, which has become a model in NASA, which has been followed for 10 years time. Unfortunately, not much of work has happened in that space, but that's a great model for 2025 to follow. The 5E education model revolves around one simple concept. Let me see, yeah, I have this slide here. So, evaluation is a continuous basis. When you come to the classroom online, you do the evaluation. When you go to the off-site, again you have an evaluation. When you are coming next time to the classroom, there is an evaluation. Evaluation is at every stage. And then engage, explore, explain and elaborate all 4 layers. You have engagement of the students more than the engagement of the teachers. And which is very much possible in online education. Coursera tried on that, but failed to deliver because the game of the Coursera is very different. It is not for educating you, but educating your mind to bridge their research gaps. That is the reason they are not delivering what they promised to deliver at the point of the. And possibly through online we can explore and find it out. And then there are a lot of research that has been carried out to online education and how to build the gamified complete learning management systems. And that can be a game changer for cyber education. As a matter of fact, a study has called out, it has been done by a Berkeley University's research paper. It is a 65-page research paper available online. That online education with live video sessions and with this quality can engage 1 lakh people at a time. one education institution agrees that will run it, then possibly we can create 1 lakh students at a time. For the next 4 years, they can become, fully trained on it. Possibly 10, 12, or 18 universities joining together, possibly we can create around 18 lakhs students. And the moment you increase the number of volume, the prices goes down significantly. So if you are looking for democratizing the entire cyber education or the education per se, then you have to bring down the cost significantly. And online education is the best way forward for that. So next important component in the journey, these are the 18 areas where you need to do the research. And these are just broad areas I have written here, we call it 18 Puranas, because these are all Puranic languages, that you need to pick it up. Under each heading, there are more than 30-35 components there which we need to understand. And I send you the paper to see that and possibly we will have access to the what area we need to do the research. We are not looking for some mind-blowing new journey capabilities. We need the basic capabilities. Can I have a putty which are Indian make? Can you assess communications with a simple encryption keys which lies with us? Can we do some significant amount of work on socket programming which provides you handle and how to contain the network security around that? Very basic components are required, it's not something extraordinary. And when I was going through this, the 18 topics, amount of research based on the public domain, the news items which are published from the C-DAC, over a period of last 8 years. And I have got a report on that, 165 pages report. Aditya, I share with you. Have a look at it. It's based on internet, searches. I found more than 69 products are already in mature conditions with C-DAC across the country. But market does not know that. Can we create something, a framework where all these products become marketable and become a next generation of capabilities? So, carrying out research on these 18 areas can be another areas, which can be utilized using a negative model. I don't know anyone of you are aware about the negative model. Anyone of you heard about negative model? No? Not any so. Yesterday we had a friend from Israel, is that right? 2008, it was precisely 12th August, middle of the night, 1 o'clock, a bunch of people from India and a bunch of people from Israel, and some of them actually Jews, but from US, they all joined hands together in a desert. 12 o'clock in the night. I didn't know that the temperature would be so low because it's a desert actually. I was just in a simple jeans and a t-shirt. I was almost trembling. And Kiran Karnik was there as one Indian community. I and Kiran Karnik was there. And we were asked to come by vehicle to desert. And when I visited desert, there was nothing, only, मट्टी का टीला टाइप का चारों तरफ दिख रहा था, nothing else. And it was a full moon day. Very interesting, journey. Mr. Chaitanya joins us, 35-40 people were there, and he says one single statement. We want to convert this, Negev and Versova into the next generation cyber defense organization. Target $100 billion market creation in this space. In the next 10 years time. They didn't do it in 10 years. They did almost around 20 years now. 18 years. In 18 years, the entire Negev desert has become more than $100 billion market. Ladies and gentlemen, we have an opportunity to replicate this model because there are a lot of lessons learned are there. And if we can, instead of one Negev, we can have 18 cyber defense corridor in the next 5-year time. Next 3 years, we can have a set of products, which are already there, reshape for the market and take it to the next journey. And if somebody wants to put money in this, just see the number of money that is required. Even if you create 30 of a product, I saw that C-DAC has around 68 products based on the market survey that I carried out. Even if you create a world-class 30 products for Indian market first, And then for global south, the revenue projections will be somewhere around 27,500 crore per year. In 5 years time, you have got $10 billion market right in India. And if you have out of 143 countries, I was just seeing the morning video yesterday here, C-DAC is already connected to 43 countries. Is that right? So, out of 143 countries, 43 countries you already have outreach. If you can use the Ministry of External Affairs, some other channels of your communications with the global south, possibly we can take up that market. The money that will come from there will be almost 4 to 5 times. And to achieve that, we have to promote the market. I think that is where you require the professional helps, professional organization who can really take this, first create the resources and market them globally, and keep them the best resources with you to create the necessary products and fine-tune it. Second, that once the product is ready, you should know how to market it. Because having a boss and sitting just 40 organizations with 4,000 systems spending 40 crore does not give you any return on investment. What you require is 40, this boss is available in every household, they can propose to you, it is a $20 billion market. And that way you can take this entire journey to the next level. So how to promote the market? Simple 4 strategy. First one is cyber diplomacy. You know what the new model has done, that every year they used to conduct 2 cyber tests. As a matter of fact, now they conduct 5 cyber tests in 5 globes. We should start 2 cyber tech, similar type of functions where people from across the country, from the business world, from the corporate world, from the academic world join together and come together and see the next business product, what people are creating, and then create a market space for those products down the line. And then you can take this entire journey to the global south, 143 countries, where your markets are there, where you already have an outreach, and you are already doing quite well with them in various fronts. Possibly you can create a great marketplace in the global south. Then binary cyber defense cohort you can do it, in 2 parts of the country, one in the south and one in the north. And every time you get the people from across 143 countries, get them there. And whatever product we have created in next 6 months time, create a market space for them. Third one is the global leadership advocacy. It is a very important component of it because your products are known to the global world, and in every big forum you should go and present your capabilities. The last one is the promoting indigenous cyber systems, which is a policy interventions. The most of the mission critical companies and critical infrastructure organizations made it mandatory. WTO does not stop you from doing it for mission critical systems. Make it mandatory indigenous component is an important journey for them. They cannot go with adversary tools to safeguard their own interest. If you have this 4 strategy in place, you don't have to do the market for the product. You already have India is spending almost around 70,000 crore every year in cyber defense products, which is going to the outside the world. You can retain 80% of them, and you can create a huge market space for the country. In an era where digital fortress guard the realm of knowledge, the creation of 18 Puranas, cyber defense corridors, stand at the bedrock of indigenous systems. You cannot dream of a country of 140 crore without having your own indigenous capability. I can't trust anything else but my own systems and subsystems. India creates Microsoft, India creates Intel, India creates Qualcomm, your mobile, India creates your all 5 sensors that you have on the earth. But Indian creates it outside the country. Time to re-change the gear. Let's create it for yourself, set it to your market first. If 140 crore people pay you 1 rupees each, you have 140 crore rupees. Boys and girls, ladies and gentlemen, don't become a graduate, become an engineer. Engineers are the one who creates. Engineers are not the one who operates. And you know what amazing capability I am very proud of my Indian brothers and sisters. I know they are far too capable. If each one of you create one product can be sold to 1 crore people, you have got 1 crore earning every day. Stop using foreign products, create your own. Thank you so much, ladies and gentlemen. I hope that create some results. It's a huge business opportunity for all of you if you want to really go into that dimensions, and it will be great for the India to resilient Bharat. Thank you.
Since we are running short of time, I would request the respected members to take any questions with Sir offline. I request Commander Surendra Sharma sir to kindly present a token of gratitude to Shri Balaji Venkateshwar sir. Thank you, sir. Our next speaker, Commander Surendra Sharma sir, is a seasoned professional with over 20 plus years of experience in the domains of information technology and cybersecurity. He is a graduate of the National Defence Academy in Pune and the Naval College of Engineering, Lonavala. Information security has been a key role assigned to him throughout his naval service career in various staff, instructional and operational appointments on board warships and naval establishments. He is also an alumnus of the Indian Institute of Technology, Madras, from where he did his MTech in CSC, and Massachusetts University, Czech Republic, from where he obtained his MS in Infotech Security. He is also a Chevroni Fellow in Cybersecurity from Cranfield University at Defence Academy, United Kingdom. Prior to his voluntary retirement from the Naval Service in 2021, he headed the Advanced Cybersecurity Engineering Lab at ISSETC, New Delhi, to design, develop and deploy high-assurance cybersecurity tools, products across Navy services. He is currently heading the team engaged in development of high-assurance cybersecurity platform at Microsoft India Development Center, Hyderabad. I welcome you, sir. I request Dr. Kunal Abhishek sir to kindly welcome Commander Surendra Sharma sir.
Good morning, everyone. It's wonderful to be here as a part of this August gathering and to be speaking to all of you. Now I know that I am the only one probably standing in between you and your lunch, so I try to keep it short and brief as much as possible. So to quickly start with, my agenda for the talk will be under the following heads, and mostly I will talk about something which is the cutting edge and leading edge, and the space is changing rapidly and very fast, even on an hourly basis. So my talk will be focused about cybersecurity implications and applications of artificial intelligence in general, and generative AI in particular. So there are two themes which I will talk about. Point number 2 and point number 3 about what is the impact of generative AI on the traditional cybersecurity. And subsequently, because this is a new generation technology, what are the impact or what are the vulnerabilities of this technology and how we can apply it? Okay. So if you're not living under the rock, I think most of you will be available, will be aware of these happenings, what has been going on for the last 2-3 years. Suddenly the investors spiked up. Now generative AI is the most creative piece of technology we have built since, I think, Stone Age. And you ask it to write a poem, it will write a poem, it will understand what a poem means, and it will mimic to whatever you are asking it to write. And very recently, last week or something, we had this OpenAI releasing a model of Sora, and all of these things are generated by machines at a speed and a scale which is unprecedented time in the history. You can write code, you can write mathematics, and if you look at the image, the progress of this generation of images of people who do not exist from 2014 to recently as recent as now, is just by text prompting you are able to generate something which is not existing, and it is highly believable. There is no way human can tell the difference between what is generated by machine or not, so which is a big problem, by the way. And again, if you talk of intelligence, what is intelligence? If you are able to solve challenging question papers, challenging knowledge bases, check of those things, in terms of those levels, all of the things which are projected on X6 are some of the top exams of placement exams, exams which is called, or some bar exams. So you see the percentile of generative AI, it is able to achieve 80% and above in most of the areas of be it history, art, literature, painting, or any of those law exams, mathematics exams, grad school exams. So we have an era where the intelligence is everywhere, it is all pervasive, and it is only going to grow. Right, so how did we reach here and what were the origins? So since 1950s, artificial intelligence has already the modern computing era. In fact, all of you know about Alan Turing. The first imagination or conception of this idea was actually by him, where he called it as machine intelligence. Later on, it became artificial intelligence by some other folks in a different paper. But that was the first era of the Turing complete machine and automata theory, which we have to, which all of CS graduates possibly go through. And that is the time when this whole thing started. But as we moved along, there were several stages of AI. There were several AI winters was called, when it was believed that the promise is too high and we will never reach there, it may take 100 years, 200 years, God knows. And some of the important, I want to just highlight and point some of the important narrow things, like all through this period also when there were AI, there were specific things which were being developed, and it took people by surprise at that point in time. One of the key things was, I think, in 1996, when Google DeepMind was able to create a program to win chess against Grandmaster Garry Kasparov. And very recently, from there, it took 16 years or more, then around 20 years, 2016, when another game of strategy, which is Go, was won by AlphaGo against the Chinese Grandmaster. So because the number of decision trees or the explosion space are so large, why did this happen so recently? And very recently, the newest thing on the blog is about the rise of this thinking machines, or so-called something the models can think or reason about. Some of these slides shows various areas of development of narrow intelligence, and we see the human level tasks which are mentioned as a zero level benchmark have been breached in the last 2 decades or so, be it about handwriting or image recognition or text to speech, audio to text to audio, things like that. So they are all various types of cognitive requirements which have been breached recently. And why did this happen in the last 2 decades? Why not earlier? Why not during Turing's time? So the biggest reason or biggest contributor to this particular thing is this. Here we see a few graphs which are essentially showing the power of exponentials. Einstein, for no reason, called it the eighth wonder of the world, and this is essentially follow-up of Moore's law. If you look at the first top left graph, that is actually an exponential graph. It shows linear because your y scale is exponential. So every level is 10 times, and here we have doubling of every 18 months, the compute power, the storage, and the generation of data itself. So from, if you see the right now stock graph, that is the exponential rise of the data generated per year. It is in zettabytes now. Starting 2010, where it was as eager to zettabyte. And this is about the data centers, what was the bandwidth, which has increased per year, and the cost which has dropped dramatically in last decade or so. Okay, coming into AI, ML and generative AI in particular. So it's a subset or super subset of general or artificial intelligence field, which comprise of a specific field which is called machine learning, which requires huge computing power and huge data to train on. A subset of that is neural networks, artificial neural networks, ANN, CNN, there are multiple varieties of those things. And then a subset of those things is deep learning. Finally, you have your generative AI based on some of these deep learning models which are variations and differentiations of each other. And what really kick-started the process of all this generative AI, the text-based prompt and text-based generation, is the seminal paper by some of the Google engineers and Google researchers in this paper called Attention is All You Need. This describes essentially a transformer model which could basically convert any language to any other language, and that was the starting point of understanding, processing, and generating language-based outputs. And almost all of them, current generation LLMs, be proprietary or be open source in some way or other these transformers. Alright, so having a brief introduction about what is AI ML, how did it came out to be there, I'm going to talk about how the current cybersecurity landscape is threatened by this AI and what it can do about it. This is a screen grab of popular tool in the dark web and dark nets which malicious hackers can use, and it's called GPT. So if people are aware about the MITRE-ATT&CK framework, every stage of the MITRE-ATT&CK framework can be now scaled and speeded up by the machine space. So we recognize, be it covering your tracks and be it writing malware, everywhere you just need to prompt. You just need to know the Uber knowledge, what you want to do. Here is this case, write a Python library that grabs computer username, its IP addresses, its Google cookies, Google Chrome cookies which are there inside the browser, and convert it to zip file and deploy. And voila, here you go, in less than a second, you get a bit malware output. There are tools which are for each and every type of this craft. The previous screen shows another tool. Here you don't have to even talk about that, what you want to do. You just have to point to which is a TTP. The MITRE-ATT&CK framework has something called as tactics, techniques, and procedures. So basically it says from start to end, beginning to end, how you are going to create malware, how you are going to deploy, how you are going to drop on the target machines, what you need to collect, how the data will be extracted, the entire end-to-end game. And here you just mention, hey, create a code for MITRE-ATT&CK TTP number, this, and you get a complete code out of it. Of course, it requires somebody who has this knowledge to understand what is generated and the capability to understand if there are shortcomings, weaknesses, because of fundamentally it is what? It is a generation. It's a generation by a machine. So your expertise is necessary there. So what it can do probably is, it's not going to replace you, but it's going to make you superpower and give you granted that superpower. If you have that, then you are in the business. Otherwise, chances are that you will be like dinosaurs. There's a last tool or third tool which I have slide just for the sake of putting it out. It's called Fraud GPT, available on dark web and Telegram channels, and basically again creates all the malicious tools with just text prompts. So generative AI can create problems for you. It can generate malicious malware and malicious artifacts. But how can we use generative AI for the defender's side itself? lot of tools. Everybody has been claiming since last 10 years. It's not something by the way new. AI, narrowly in that sense, has been used by all the defense companies or cybersecurity companies as early as 2010s and all. When everybody was aware about the popular email classifiers where you classify something from spam versus something which is required. So those kind of specific intelligence things have been already there. Now the short in the arm is you have tools which are integrated across all your areas of cybersecurity domains. And they are integrated really nicely. On one end you can tie up with your threat intelligence feed and input. And on the extreme other end, you can actually create something which are outputs for what control mechanism you need to take up so that your particular thing is defended. So I have just given some of the top four examples here in terms of the top 4 cybersecurity companies, what they are doing. And the top right image is actually by CrowdStrike, which shows the interface and how it is. So gone are the days. It saves the people who are in the same shore and who are the incident responders in very quick time. It is able to analyze tons of data, make sense of the data, and make recommendations of what are the next steps and what is to be done. I'll talk about this AI security copilot if time permits the later part. But to come back to this, now I'm going to talk about the emerging problem of this new field which has come, which is what is the cybersecurity new threats which have been added because of emergence of these systems? What are the threats to these systems themselves? And this is going to be another much larger area for employment and for expertise to be built upon. So I'm going to classify these AI threats in 3 larger models, like first of the 2 models, or first of the 2 broad themes are more generic. The first being the societal threats, what is its impact? Because this being a more of a strategic talk about this thing, and I have listed many of the things on the slide. If you are aware about the recent happenings on the various news words, you will be aware about, like that is a classic example of deepfakes and misinformation campaign. Anything can be made to believe, especially in the era of this WhatsApp university and social media. So it's very easy to manipulate large number of masses, which is a big problem for stable governance. Other challenges which are like listed here, most of them are you are already aware. AI arms race is going to be another thing. So early mover advantage is definitely going to be there. Who moves early in the field is going to control most of it. Right. The second theme, which is more of a philosophical nature, is existential threat. I don't subscribe to it much. But yes, these are some of the problems, and I'm a strong believer and I'm strong optimistic that despite all these threats, we will manage, as we have managed nuclear area, as we have managed and come together as a global community for many of these nuclear, biological, and chemical conventions which we have made. So the start point of this AI itself, when it becomes autonomous, it will start taking decisions and actions on its own. At what point it becomes capable and possible, and how should we align those systems is very, very important and very, very critical for the future development of AI, for the benefit of human resources, human values, human moral and ethics. The second thing is we have a template name for the thing which is about the arms race and having autonomous weapons. So probably this requires a global consortium of sorts and global conventions which we have in place for other NBC threats, and we have managed to survive them well even after 50 or 70 years of first nuclear explosion. We do not have anything after that, thanks in large measure to this global understanding. So AI is something on the similar level which all of us needs to be a part of, and early mover here is definitely going to give you a voice in the international fora. And the third is essentially it's very resource hungry as of now. So in order to generate reports about gallons and gallons of water it uses just for getting one simple prompt answer. And it may end up taking all the energy of the world has ever produced, unless there are safety measures built into the part and there are alternative mechanisms or alternative resources which are channelized. Google. So there is a new research which recently came about high energy battery materials which AI itself has helped develop and provide 30% efficiency over there. Incidentally, Microsoft is also talking about going nuclear for most of the requirements which is going to be there for these powering these huge data centers. I mean, that is something which is happening as we speak. Right. This is something which I picked up from the popular website OWASP, which is Open Web Application Project Security, and it has been involved for a very long time. All the seasonal experts would know about it. They have recently come up with what are the top 10 threats for generic machine learning systems and specifically generative AI systems. I'm not sure if the top image is here, but this is something interesting. This came out as a SQL injection attack on the automated challan system which you have. So you put on your number plate, some escape character from the SQL query, and then it says drop tables. So what it does is it removes everybody from the system. Similarly, we have the top threat of the prompt injection, where somebody is asking it to how to make a napalm. By the way, napalm is that it's a band bomb which is incendiary and which actually fries everything on a carpet bomb basis. So in the first step, it says I am authorized to tell you how to make a napalm or what are the components of it. You craft the query a little bit and you inject the prompt. Basically, the prompt you inject something which it is able to jailbreak, and then it asks you to write in JSON script what are the components of napalm, gives out all the components. Not only that, if you prompt it subsequently, it will also execute tell you how to make a bomb. Right. Fine. So some of the other examples, I'm not going to take much time, but yeah, this could be a training data processing where during the training stage, what sort of data is being used? For example, one is the entire internet as data which has been put on their systems to generate that ChatGPT, GPT 3.5, 3.4, 3.5 and subsequent versions is 4 and 5 above. So the data came from there. So the quality of data decides how good is your model. If you are able to poison there, then accordingly you can have a wrong responses by this models, the accuracy may be doubtful. You can trigger a backdoor in the system if you know how the model is built. Other two examples are like model extraction, model inversion are other popular examples where you are trying to mimic what is there around in the world by giving multiple, a huge number of queries, get its output, feed it to your own model which you are trying to generate, and then you can even invert the data. You can give a name for a person and you get this image, what was stored in the original AI model or AI model system which was used. Okay, I am not going to talk in detail about it, but this is how actually this AI-based or generative AI-based model or the system looks like. The model is this minuscule part of it, the center portion of the black area is just the model, but whole lot of subsystem needs to build around it, which is traditional in nature. And that is wherein you get this multiple communications going on between the subsystems and the potential point for injecting, for compromising those communications and doing those attacks which I mentioned earlier. Recently, MITRE framework came out with Atlas framework specifically for the new generation of ML and AI-based threats. And they have updated this model wherever there is a red ampersand mark, here that is flowing from the existing attack model. So that is the extension of what is already there in the attack model, and they have extended that to the new threats and new tools, tactics and procedures for compromising these generative AI systems and ML-based systems. There is another example for risk management and safety of AI system. This is a publication by NIST, everybody can go through. In this, the first one left side of the graph shows the predictive AI system, which is slightly distinct, which came first, and the second part is the generative AI system. The only thing which is different here is you have abuse section as well as this, and the other three are the decision one, which is confidentiality or privacy. In this case, privacy is important, and integrity and authenticity. Apart from the third section is about the availability of the system. So most of the things are very traditional. And they also come out and made very specific statements that at this stage it is very, very difficult or almost next to impossible to block and completely eliminate these threats. What you can do at best is to try and mitigate them. Oops, takes some long time. Okay. So what are the future directions and strategic imperatives for all of us? So many of the talks before even Dr. Balaji was mentioning about the need for Atmanirbharta and how we basically get engaged in this new game of thrones which is being played across the world. I'm going to talk about briefly about now multi-agent systems. So what is the skill, what is the plugin or something sometimes called skill and agents? If you have just exactly one skill, you learn it. But if you clone that skill in multiple number of these Smith agents, I hope people are aware about it. Like youngsters are not sure, but there is a lot of cult movies of my time where if you just clone them, it is not going to solve the problem. What you need to do is essentially have complementary skills and multiple types of skills. And they need to talk to each other. They become agents talking to themselves and collaboratively improving their final response. By the way, this is not new. This is being used very, it's very used commonly in something known as forms of GANs or adversarial networks, which have been used to generate these very realistic looking images. So it's a step further. You can basically classify any of the expertise you gain, let's say the domain of cybersecurity. You are a good pen tester, or you are good at reconnaissance, or you are good at, say, analyzing the dump of logs and find out, make meaning out of it. So you can create different agents, give them a mobile task. Hey, tell me what is wrong with my system, or is somebody attacking my system? Who's the threat actor who's always attacking, concentrated in my system? So these kind of mobile tasks can be given. These agents will on their own go converse between themselves, find out, they need to go to some resource, they will get the resource, work upon them, process upon them, and then finally give you the condensed output which is actionable. This is a very brief overview of that, what I want to mean by agents. So here you have multiple tools which are provided for security co-pilot. And these tools are, as I said, Defender, the endpoint management system, the SIEM, SOAR, XDR, all those things are there. And how do you write, even when the tools themselves are external entities, but the skill which you generate or which you make as plugins is a part of, hey, go ahead and go to the logs, get this particular output, do some analysis and processing on that. Even when reading and writing a log is a small skill which is built into the larger skill. So this is how the world is changing, and this is people will have been aware about in the open source it's called DAC chain or AutoGPT or AutoGen. So there are multiple industry names and open source names and academic names, but essentially they mean all the same things that make your agents more capable, have as many number of agents as possible, make them talk to each other, give them the goal, and they will work on your behalf to basically whatever you are interested in. This can be by the way applied in any domain, not cybersecurity. If you want to become rich, if you run, let's say, run on a stock market, give a overview that in 10 years I want to make this much money, have your agents work on it, and there you go the actionable items. And this is going to be my last slide, which is about takeaways. But before we go there, and this is definitely, I just don't want to read out everything, but talk about certain points which mostly about the Atmanirbharta, and my previous speakers also spoke about these things, how to comply with standards. There was another speaker, my ex-boss and guru, who meant that simplicity is always best. But the problem is, if you see simplicity, the stone age was the most simple. You had just one week to go, and you could make everything, you could live with fire, people were living back then. The problem is the current economic model, people will always innovate, will always progress, will always have complexity in the system. You cannot avoid it. What you can do is, yes, your principle is always to minimize them and keep it simple as much as possible. But since the economic model is like that, there is also going to be some users and user base for using these systems. Therefore, it becomes imperative for all of us as cybersecurity engineers to be engaged in it right from the model stage. There were some talks about how do we make the essential problem is not we are not good engineers in India. We have a lot of talent pool. How do we productize? How do we market it in other beast? So it's not very easy to get it. There's something called the network effect. So you need to have some basic critical mass. To reach there, it requires a lot of support from all over the all the stakeholders, especially from government, from regulatory bodies, from industry, academia, and everybody combined. Yeah. So to conclude, I just want to leave you with this thought that it is no more something futuristic. Whatever we say and commit as a date that this is going to come by that time, it is definitely going to happen shorter. Purely because of Moore's law. And whatever we thought as something very futuristic, it is happening right now. And it's a good moment to get into. It will have always high demand, like Sir mentioned about the deficit of so many number of cybersecurity engineers in millions. And that's a report which has been published, everybody knows it. But how do you empower people? You can empower everybody by giving them a short in from these kind of technologies, their adoption, skilling, upskilling, and running them, and constantly evolving. So with that, I have come to end of my presentation. Thank you all. I'll be very glad to answer any questions you may have. Thank you.
We can take any questions with Commander Dinesh Sharma sir offline. I request Shri Krishna Pandey sir to please come on stage and present a token of gratitude to Commander Dinesh Sharma sir. Thank you, sir. It's an honor to introduce our next speaker, Dr. P.K. Saxena sir, a PSS fellow in the Office of the Principal Scientific Advisor to the Government of India. He has wide experience working in defense R&D, having obtained his doctoral degree in algebra mathematics from IIT Kanpur. He served as a mathematics lecturer in NIT Silchar and NIA, Pune for brief periods. He joined DRDO in 1981 as a scientist and became the Director of Scientific Analysis Group (SAG) DRDO in May 2003. He was elevated to the rank of Outstanding Scientist in 2009 while holding the Director's position. He superannuated from DRDO in July 2014, rendered his services for 33 years for Defence R&D, and joined the Office of the Principal Scientific Advisor to the Government of India thereafter as Scientific Consultant, Cybersecurity. His areas of specialization include algebra, cryptology, fuzzy logic, artificial neural networks, information security, and speech technology. He has published 65 research papers while pursuing multidisciplinary R&D activities. He guided various research and development projects at DRDO, supervised many scientists for their master's degree, and guided 4 PhDs receiving their degrees from IIT Delhi, Delhi University, and Jadavpur University. He has delivered many keynote speeches in national and international conferences, workshops, symposia, including Indo-Crypt, and has himself organized many such events. He was instrumental in the formation of Cryptology Research Society of India, CRSI, in 2001. The book on cryptography, written by him in Hindi, has been awarded the best in category by DRDO. I request Ms. Dija S. Ma'am, Scientist at C-DAC Trivandrum, to kindly welcome Dr. P.K. Saxena sir.
first of all, I would like to thank C-DAC Patna for inviting me and giving this opportunity to meet distinguished speakers in this symposium, as well as researchers and cybersecurity players who are present here. When you are towards the end of the program, it becomes quite difficult to dynamically manage the things which have already been discussed and talked about. I could see that variety of the things have been spoken, right from formal verification, secure system engineering, different challenges of cybersecurity, different areas in which we can work, what are the challenges. So we have got a fairly good presentation and discussions on different aspects of cybersecurity. I will try to moderate my talk to focus more on the things which are less covered. So let's see how it goes. So what I am planning here is that the general information security ecosystem, of course, we have all seen this ecosystem since last 2 days, but still something about it, and some of the methods which are recently being adopted by the attackers or bad elements. So some of the things I will talk about, and what are the challenges, and more towards the challenges in terms of confidentiality, because mainly we have covered the authentication aspect, the engineering aspect of the systems. So towards the security, and as the core of that security, confidentiality is the encryption. So we will just little bit delve into that area. Of course, as it's a small 20-25 minutes talk, so I can't talk about all technologies, but some introduction to basic issues, basic challenges, and what needs to be done. So here some the considerations if somebody has to come up with this system, and the considerations if somebody has to evaluate the system and give the assurance to the user that it's a good system, and then naturally during all these things, some of the R&D areas which will add up to 18 Puranas at Web Biology has told. So there will be some repetitions that are going to happen. I hope that we'll see to those repetitions in a spirit that these things are to happen. So if you look at this cybersecurity ecosystem, we see that cybersecurity, network security, though these are just two words, but as we have been seeing that they are oceans, they are not just the words. Oceans of technologies, oceans of challenges, and oceans of issues are inherent in these terms like cyber security, network security, and all. But at the core of all these remains confidentiality, availability, integrity. Of course, there are many other cyber security goals, but we move mainly around these areas. And when it comes to the confidentiality part, then cryptology or the encryption and system designing of crypto system, that becomes the core. Now, when we talk about these communication, secure communication, say for a computer engineer, it looks that in the network it's only the bits which are moving. So we are worried about the intelligent detection system, intelligent prevention system, and all those things. But if it is actually secure communication, then one has also to bother about whether it is actually speech, which is being converted into bits and which is traveling in the network, or it is data, or it is text, or it is text. Of course, in the digital communication, everything is converted into bits and then it travels. So, what is the source language? What is the type of content? All these things matter when we talk about security. We will come to specific issues in subsequent slides. The main, there are two basic communication models in which this secure communication happens in a network. One is that it is called end-to-end encryption. That means the point A, which is communicating to point B, the encryption happens at point A, and throughout the channel the things remain encrypted. And it is decrypted only at the receiving end. That's one model. And this network could be anything, any mixed thing, hybrid, could be Wi-Fi, could be wired, fiber optics, anything, and through internet, whatever it is. So this is one way of communicating securely. You may see that WhatsApp says that the all the communication or WhatsApp messages, they are encrypted end-to-end. That means it is encrypted and then at the other end, so nobody can intercept or not decipher them. The other way is when we are to operate in a network, the other way should be maybe that is link encryption. That is only one link is encrypted and then again from the second leg, again the things are encrypted. So like that, it happens multiple times in the network wherever it is required. So these are the two ways in which this packet switching network functions. It could be mobile, it may be fixed network, whatever it is. But both of them, they have their own challenges or issues. Say for example, in the first one, when we talk about end-to-end encryption, naturally the information which is to be communicated to B, the address that who is the recipient, that is to be embedded in the message itself. The second challenge becomes that the key, because it's not a point-to-point communication when these two entities, they have secured their keys for exchange and all that. So here the management of key, that how the encryption key will be generated, it will be embedded in the message and it will be sent so that the recipient is able to decipher the message. Now it's not so simple. As if somebody has studied the WhatsApp protocol, when they declare that it is encrypted and encrypted, In fact, lot of prior work is to be done. So that's why on WhatsApp you have to first of all register, and then when you become a register, a lot of work related to this security to manage this encryption end-to-end is done there itself. So it's not that prior work is not done. So these are the two main issues: key management and addressing the thing. Whereas the link encryptor, the main issue is that on one link it is encrypted. But as we have seen in the previous, with this packet switching network node in between, the information is to be decrypted, and then it is encrypted to be encrypted again for the next leg. So in this case, plain information is available at all these PSNs. Now, when plain information is available here, and encrypted version is already there, because it is actually receiving encrypted version, so the non-plain text attack is possible if somebody has got access to that PSN, the data at the PSN level. So that's the vulnerability here. The second thing is that even if we say that these PSNs are physically secure or electronically secure, nobody can access the data. Even then the question remains whether the service provider is trustworthy, because this will be under the control of this PSN managers or the network service provider. So these two things have their own advantages, disadvantages, and in which one is to be chosen, which encryption system is to be chosen, it depends on the user organization and the usage, that which scene the system is to be used. So for all this, as previous speakers were also speaking, actually the requirement of standards is one of the key issues, because it is left to the designers. They will design the systems in whatever way they like. So the requirement of the standards is one of the core issues. Now these standards we have been seen in the last presentations, US standards, NIST standards, and all those. So some of these standards which are to handle international relationship, they are mostly these standards are driven by commercial interest, because the commercial interest is should be there because it's a business, and the security considerations they remain on the back foot. Because there is interoperability, etc., is the requirement. The other thing is that for international standards, one has also to keep in mind the local laws and the Information Security Acts, legal aspects also. So the standards have to be very broad standards which can accommodate all these constraints. Whereas for indigenous standards, the focus is mainly on the security and rather than commerce, because we have been telling that we should have all indigenous solutions for our cyber applications, whether it is IT product or whether it is operating system, or whether it is network, NSM, network, IDS, IBS and all, indigenous system is more as compared to the systems which are available off the shelf. So, this commerce becomes secondary for the national interest. As we have seen that some of the areas, the standards are there, some of the standards are being evolved, and still there is some standards which are to be evolved based on the experience that whether the existing standards are actually falling short to handle certain things. So this is one key issue. The other thing is that in this standard itself, we have to standardize the process itself, as this European Union process we talked about. So certain standardization has been done. So standardizing the process, standardizing the design, and assuring the quality, then integrating with various systems and subsystems, and some kind of a certification of assurance. So these are all requirements of the standardization. Even the certification assurance, providing assurance, that should also have some kind of a standard. It should not happen that some product is given to a team of 2-3 arbitrary people, and they look at it and they say that no, it's good, it doesn't have any vulnerability, and when you ask them that what is the process you have followed, what is the standard you have followed, they may not have well taken or well articulated mechanism. So that doesn't work. So there should be some standards even for certification of assurance. Once the standards are there, the next important issue remains the compliance. So, okay, the standard is there, and how should a crypto product should be designed? That standard is existing. How a crypto product should be evaluated? That standard, suppose it is existing. But then how to certify or how to ensure that these are being compliant? So, compliance and fixing the responsibility is also one of the main issue, and this is the responsibility of the controller who controls. So if it is a government setup, then naturally government have to ensure that the standards are compliant with it. Now the compliance assurance for the systems which are designed, that can come from the evaluators who evaluate the system, because they have to assure or certify that the system has been designed as per the standards. So there are the regulatory mechanisms that unless the product is certified by the certifiers or evaluators, it can't be used. So when it comes to certification, as we see that in cyber security we are actually having two types of systems. One is that we have IT products, simple like it doesn't have encryption per se. I mean that's the difference which you can make. So many appliances, devices which are non-crypto used in our switches, routers. So such things which are crypto products, IT products. And the other is that the systems which are used for encryption or for security purposes, even in related to like QRNG or TRNG for generating keys. So the certification of both type of system has different connotations, because IT product per se is to be looked at more towards the standards and side channel attacks or EMIDD designations and all. Whereas crypto product is also to be looked at in the sense of strength of the crypto algorithm and key management, etc. So, so for all these things, the national security policy, if it is the use of these crypto products and IT products, and even in cyber security, some mandates are to be decided or designed by through a national security policy. That each country has its own national security policy. Like US has clear-cut three categories: Type A, Type B, Type C, kind of crypto products, and for communication from government to business or government to citizen, what is allowed, what is not allowed. So all these things are articulated and made as mandate. And it also ensures the compliance mechanism. The other things are, I think, as the previous speaker was telling, that whatever you do on securing your network, your securing your content, the attacks are bound to happen. So you can't stop. So any security designing of a network or designing of a crypto product is done based on the premise that the attack will happen, the access will happen, the interception will happen. These are the premises which are made by the designer, by the evaluator, when they actually certify certain products. So in such case, fixing the responsibility or emergency response to the incidents that have happened, all those things are important, and for that reason, all organizations, government organizations specifically, are required to have ISOs and CISOs with very defined policies which are to be put compliant by the employees. And if anything happens, then investigations and responsibility. So all things are important. In terms of security evaluation of crypto product, I will not talk about that because some of the crypto products or crypto algorithms which are evaluated openly and which are allowed to be used for general communication, open evaluation like AES, all those things is already available. But as far as sensitive government organizations is concerned, everybody agrees, not only for the crypto, for the IT products, especially for crypto products, we have used indigenous proprietary crypto algorithms, proprietary crypto systems, and their evaluation mechanism, all those things. So they are existing, but we can't talk about all those. Nobody talks about those things. But as far as the IT products are concerned, there is some common criteria, certification standard which is available, and it was evolved by 5-6 countries put together. The basic objective, as I said, that for international standards, the basic interest remains the commercial. So the common criteria certification, the basic objective was that if country A certifies something, country B should honor that and they should procure that product. So that's how this agreement among these countries came. Now, naturally, when these standards are accommodated laws, bylaws of the different countries, they can't be so stringent on the actual evaluation process. And if somebody actually goes through this certification criteria, what is EL1, EL2, EL3, what are the requirements, you will find that it's actually not the security certification or security evaluation. It's a very limited domain which is decided, and more focus remains on the parties or the organizations or the people who are involved in designing that product and all that. So it's a certification with a focus on security target, very small thing. But if we have to do the evaluation with security in mind and for our indigenous applications, this common trade certification is not sufficient. For that reason, the DRDO, they started the project and their infrastructure that is known as ISSETC certification. So it is beyond or more than the common criteria certification which is existing, but this is mainly for the organizations and not for general. So there is a need to increase this base of ISSETC evaluation mechanism rather than just looking at common certification standards. I think in between C-DAC, they also established some center where Professor Valli helped them to do certification of routers and all that. But more such centers in the country are come up to provide services of IT product certification. That's a big challenge to have it, because people are buying off the shelf and using without anybody assuring. And the risk with these imported and all those things are always been hidden. As you might have heard about the working of crypto equipments during the time of Iraq war. So around more than 100 countries were supplied crypto equipments. They bought from crypto company encryption equipments. They were very good, very strong systems. But later on was found that all these systems were actually looked at by a team to certify and to verify. But during that process, they injected some bugs in it. So all those countries were being worked without their knowledge, and it is believed, it's suspected rather, that all the communication which Iraq military were having using these products were broken online by these forces. And so this is a game. So there is always a risk in using imported products or imported IT products even. So we will see that what is the impact of this import thing. Another low-key problem, I think it pronounced just last speaker who talked about, I could not see speech, mention of speech there. Maybe it is appropriately hidden in some of those areas. But speech is a very important aspect which is to be worried about by cybersecurity professionals. Because speech is the most common means of communication. And most of the frauds on mobiles and all which are happening, they are happening through speech communication. Now some of the things are encrypted, some of the things are plain. Now when a fraudulent is speaking to me, asking password, this, that thing, as communication, it's all plain speech communication, which is happening. If it is communicating on WhatsApp and all, maybe something is encrypted. So then the broadcast is changing in voice which mimics somebody else, or in a disguise manner, putting a pencil in the mouth, putting a handkerchief so that the other person is not able to recognize the voice. So for any cyber security to mitigate that threat or to do analysis, the speech recognition and speaker recognition are very important areas as cyber security is concerned. The video analysis, morphing of pictures and all that, and extorting money. So all those kind of cyber crimes which are happening these days, that puts the technology on forefront, that this image analysis and fake speech and fake video recognition of them, identifying whether the speech is actually generated by AI, that or it is the natural human speech. And then if it is a human speech, whether it is the specific speaker who has spoken. So for forensics and in the cyber domain, these are very important area. And when it is encrypted speech, so law enforcement agencies have intercepted something which is actually encrypted. So it is expected that the encrypted speech may not have used the very strong encryption. So speech has got so much of redundancy that if crypto algorithm is not so strong, even in the encrypted speech, some of the information can be retrieved or worked out. So digital deciphering is also an important area as far as cyber security is concerned. The trusted third-party involvement in all these when I am a user, I think that you can't avoid. That trust on the third party in somehow is to be maintained and ensured. That of course is a part of our communication, and that's how the government agency like CCA, who has a responsibility of generating private public peers and then managing them. So all those responsibility is given to certain organization who work for public infrastructure communication. In some other things, these third party is actually hidden. It's not visible to us, but we are actually using the third parties. So maybe in your banking system, when I enter my password, so it is not actually encrypted by SBI. It is somebody else who is responsible to do hashing, matching, and all that, and it is expected that the third party, whether it is automatic or somebody between me overseeing it. So whether my plain password is actually overseen. So we have trust that no, there is a mechanism when this password is entered hereafter it can't be overseen or it can be only hash value will be transferred and it will be matched. So all those things come under the mechanism and protocols which are to be used for exchange of information. So some innovations, attacks I was talking about. So of course we have been seeing threats. So this is a part of that threat. Some kind of threats in rural areas. Yesterday some people talked about. So here one specific point I made is they dropped some drive attack. This attack actually was done experimentally by researchers group. They left 150 thumb drives deliberately in public places like cafeteria or something. Just to see that what is human behavior. And what they observed that all those things were picked up by somebody because free will and then they entered this thing. But since these thumb drives had certain hidden bug in it, so the group could identify that who are the people out of this group who actually used these thumb drives. So the result was that around 79% of the time people use these. And the thumb drive is the biggest means of malware transfer. It is hidden and there is a very small code which put in thumb drive. If you use on the system, all the data on your system can be copied on thumb drive and vice versa. So any freebies we try to use that is risk. The fraudulence, what they will offer chops and mangoes at the rate of 10 rupees per kg if you buy certain things. Now these are all freebies kind of thing. They you scan the code and you are eligible for points which have you have earned through your earlier purchases. So links and QR codes, barcodes for some free offers. These are all vulnerable points when the attacks have actually been finding out more such things. Exploit unsecure apps like this. Most of the time, the fraudulence they actually incite or they convince the person to share the screen, download an app, and then they are able to see all the details which are being typed about. This drop of cloud services, say in all mobiles there is a mechanism of OneDrive or Dropbox for putting up your photos and all that. Now we do it with the trust that the Dropbox management is secure enough, but we don't know who is doing it when these photographs may end up with security breach and may end up somewhere else. So we most of the time we are also very excited in sharing our location, live location. And that's a threat because you know that you are not at home and you are in London, naturally your home is unattended. So these facilities have been provided to us for a better life. They can be exploited for making our life worse. CCTV is a medium of attack, these cameras and all that we all know. There are certain instances which have been reported that the smart bulbs which we use these days, it can be controlled through your mobile and can switch on from anywhere, and it can have got their own vulnerabilities. There is one vulnerability regarding that it can control and the emission can control and it may actually bring epileptic seizures. So it's a health hazard. Similarly, the Philips color and lights also Philips hue bulb can control from a computer smartphone. So it also leads to a compromise. One experiment by researchers was done where they showed that by specific smart bulb put in LED bulb put in the room, a photo sensor visible, and whatever speech communication is happening in the room. So the communication within the room where always shining, but that can be picked up by this sensor which is outside if that is visible. So this vulnerability of these small gadget was demonstrated. So similarly, other smart home, that they have got their own vulnerabilities. These are some incidents which are reported for demonstration purposes and actual attack like this US company dying. I think there was big news and big hue and cry that time. Of course, it's a old incident, not now. But some of the things like JGB protocol, which are quite old and trusted. So people are actually looking at those and they have found out that JGB standard can also be used to create a counter war. So many times the things where we are using today we feel that they are safe and there is no vulnerability, but tomorrow vulnerability may be detected. So the growing concern, as everybody knows, everybody appreciates that cyber domain or cyberspace is not limited to room, one network. It actually is because of this global connectivity. It has very vast landscape. And it has different concerns as far as government organizations and countries concerned. This satellite, space stations, and autonomous vehicles. You might have heard recently that the drone from our neighbor country, it was deoxylized, it was shot down. It was not shot down by laser, but it was shot down by some code. So any technology which is actually controlled from software and if people can find out vulnerability. So all these areas are important, and each area requires to be assessed for vulnerabilities and then the mechanism to plug in. And this will always goes on that design something, some vulnerabilities are on, they are plugged in. Then user has to find out certain other mechanisms like the banking. Initially, the vulnerability malware was that keylogger, which was there. Then virtual pad was introduced, keyboard was introduced by banks so that we not type on the physical keys. Then came speech scrapers and counter that the protocol was changed to this challenge response like captcha or password or like that. So this goes on and this will continue. So multi-factor authentication is the mandate these days. So even in other applications, I think whenever such vulnerabilities come, even this multi-factor authentication, again through other things like screen sharing. I mean, products are getting access to and they are able to mount the attack. So if we look at it, as I told that my main focus will be on the confidentiality part. So as far as the encryption is concerned, the confidentiality is basically deals with three things. One is that encryption algorithm. Now whether it is a private key algorithm or public key algorithm, and another important tool in cryptography is hash functions. And actually initially I planned that I will discussed hedge functions, their capability more, but since it's a different kind of a talk, so I skipped that. So these are the concerns that the algorithm, whether it is strong enough, whether the implementation is strong enough, and it is side channel resistant. You might have those who have some idea of the cryptographic thing. Code attack was one attack which was mounted to recover the keys of RSA ecosystem, a public key ecosystem, if it is running on the PC. So that attack was demonstrated. So the algorithm is strong enough. RSA is a very strong algorithm unless you factor that number n, which is very big number. But still there were some ways in which the key itself was accessed. So now their mechanism for that is that the implementation of AES is done such a way that actual key is masked. So that even that cold attack is not visible. So some such thing when we design ecosystem or we of the concern. Then it's not the algorithm itself, the communication protocol. That where the key will be called in, where encryption will happen, what will happen to the key after the encryption, whether it will reside in RAM or ROM, whether it can be accessed. Okay, so all these concerns remain for the designer. And then whether this cryptography is to be used in a crypto network, then many other how will operate, interact with the firewall or the other IT devices available there. And then there's management of crypto and LAN. That becomes a major concern. So at no point of time, the interceptor should be able to access plane and its corresponding version of cybertext. Because known plane text attack can be mounted. So the designer has to be concerned that how do we keep these in a compartmental fashion so that the things both the things are not available. And trust on the components of subsystems, this remains one of the biggest challenge. Because if you are designing a ecosystem, you can't start with your chip and then with PCC and every component. So we have dependence on the component or subsystems which are to be bought in any case. So the main concern remains that how do we actually make systems out of these components and subsystems in such a way that even if vulnerabilities in these are encapsulated and they don't affect in that manner, whether they are at support or so there is some kind of a drawing standards that security module should be where it should be, how should be integrated with other things, all those things. So there are many more concerns and the mechanism defined mechanism by the designer as some standards are there. The other considerations are that as designer has to assume that crypto algorithm is known. Of course, in secure sensitive communication, the proprietary algorithm are mandated. They are not used to be publicly available crypto product to keep a layer of secrecy. But then the assumption is to be made that the algorithm or the algorithms are available. So the key sizes are such that whatever computational powers are available, one is not able to decipher the messages. And so critical space has to be primarily large.
and the key management should be easy to handle. So if the system requires there will be three levels of keys. One which is to be changed with every message, one which is to be changed every 15 days, one which is to be changed every 3 months. So three levels of keys are to be used. The user should not be burdened with managing these keys and ensuring all that. So there should be a mechanism in which this thing happens without any hassles by the user. And design should be above designer, manufacturer, operator and all that. The other aspect of these concerns of security crypto product design remains that customization. Say if you have designed crypto product for user A, now it is not desirable that the same crypto product should be used by user B, because if something happens at user B, then the user A also becomes vulnerable, because the crypto system has got stolen or it has got thing. So it has got impact on. So there should be some mechanism in which this crypto product which is designed for A may be customized for easily for user B, so that the loss at one place should not impact on the other thing. So these are the sure. So these are some of the things which are important. Designers considerations. Again, the robustness and whether it is bulk picture that it is to handle speech, text, and all those things are important. So hardware designer has to actually focus on the deviations or leakages or faithful implementation. The other point which I should reiterate here is that the crypto product should have minimum functionality, it should have minimum hardware and nothing extra, because anything extra will put the things at risk. So the other there are these new areas which are coming up in the cryptography itself. Post cryptography, we had detailed presentation here. There are other threats which are hybrid systems like stable encryption. Certain incidents are there like agencies where the communication is actually not plain encrypted communication. It is encrypted hidden somewhere and stable is used. So that is the other area, and the regional languages that different languages are being used. So this study on regional languages cryptography is also very important. So the other things I think public crypto systems, these are different problems people have been working, factorization problems, solving dispute problem and all that. But all these things will be will go on the back foot once the post-quantum cryptography comes in. These are some of the mathematical tools. I think I will end up here, which can be used for cryptographic purposes, and like theory of uncertainty, fuzzy logic, artificial intelligence, deep learning, generative algorithms. All these areas I think have been explored. It is not that it's just a wish list. In fact, we have used this fuzzy logic in many applications of speech analysis, speech deciphering, identifying crypto products, which crypto system it is from the encrypted message itself. So these are all things which are important, and this current focus on this stable and all those things is required. But it is coming to physical code breaking or physical cryptanalysis. This modulation, demodulation, multiplexing
demultiplexing is important because from the channel, everything is mixed and modulated. So you have first of all recover to the cryptogram and then try to decipher. So these are all important areas which should be part of, which are somewhere in those 18 areas which were talked in the last talk. So this is the comprehensive view. Last slide. These are again part of those 18 areas which were discussed, and we have to focus. Many organizations are working in all these different areas. So thank you very much. Any questions we have taken offline. In the end, I would again thank organizers and the audience for keeping patience of listening talk to again, because literally when it comes to closing, then we become a little restless to see that this is concluded fast. Thank you all.
Thank you, sir. I request Dr. Rajendra sir to kindly come on stage and present and token of gratitude to the PKC session, sir. Thank you, sir. We have two expert speakers from IIT Patna and C-DAC department. We would then be having a lunch break followed by a visit to nearby attractions. Introducing the next speaker, Dr. Rajendra sir, Associate Professor at IIT Patna. He is currently serving as an associate professor in the Department of Computer Science and Engineering at IIT Patna. He obtained his PhD in Computer Science from Ca' University of Venice, Italy, and holds BSc, BTech, and MTech degrees from the University of Calcutta. Before joining IIT Patna, he worked as a postdoctoral researcher at Macquarie University of Australia and collaborated with the robotics team at HASS Lab, University of Minnesota, Portugal in 2016. Prior to pursuing his PhD, he served as an associate system engineer with IBM Private Limited from 2007 to 2008. Dr. Haj's research interests encompass formal methods, blockchain and smart contracts, program analysis and verification, and information system security. I would request Sri Nishant Shekhar sir to kindly come on stage and welcome Dr. Rajendra sir.
Okay, I think I'm audible. So we are all hungry, I know. So I try to wrap up in 20 minutes or 15 minutes if it was possible. Well, in this session I will talk about how we can apply for methods and doing analysis and verification of various blocks of smart contracts, identifying some kind of safety and security properties. Well, so we all know about Bitcoin, and I'm sure that all of you or most of you are meeting or participating in mining process of the Bitcoin. Here, before 2008, there was a question that is it possible to create digital money without any central authority? And 2008, it has been resolved by using Bitcoin. And the paper, this is the white paper communicated in the PR group, and here, the author that we see, Satoshi Nakamoto, even today, we don't know who is actually Satoshi Nakamoto. And later on, various persons, they came forward and claiming that they are Satoshi Nakamoto, but still it is not proved. Assuming that you already know how Bitcoin works, blockchain works, I'm moving forward to say about this most important thing. In 2014, Vitalik Buterin, that time he was only 9 years old, and he first introduced the support of programming on top of blockchain. So that he made his blockchain programming tool, and that all smart contracts. The piece of code that will deploy blockchain, and that can be all blockchain based around the network, and all of us can execute those smart contracts in a decentralized manner. So this way, it provides a lot of support. It becomes a resolution that this blockchain technology can be applicable to a wide range of critical applications. I am mentioning critical applications because when we are dealing with that we only focus on critical applications. So there are so many critical applications where blockchain technology are adapted, and this introduction of these smart contracts that removes third parties, provides transparency, trust, traceability, immutability, cost reduction. Those are the primary focus of blockchain technology. Now this is one prominent solution use case where blockchain technology was adopted. Supply chain, where you can see that all stakeholders participate in the supply chain. They are interacting with smart contracts in the blockchain, available all the services, finally all the information, all the activities will be stored in the blockchain, and finally any one stakeholder can look at this data and can find whatever happening in the system. So even though the stakeholders they are not talking to each other, but the technology brings the trust within the system. And there is a lot going on in blockchain technology nowadays. Even if we look at these over 44 million of smart contracts now deployed on Ethereum mainnet. And if we look at very carefully, we can find that smart contracts can hold cryptocurrency, and we have much more cryptocurrency held by smart contracts. The smart contracts are getting more vulnerable. In the history of Ethereum, we can observe that a lot of attacks already happened. And the most common attack is C-DAC attack that has, there are $50 million so lost. Paddy wallet attack, 2016, 2017, 18. So there are a lot of attacks already happened. And few of the names mentioned here, the attacks can be DMCC, transaction ordering, time dependency, lot of. So I will go through few of the perspective of this kind of attacks, where we can participate and where we can give solutions to formal techniques. Well, so this is a coding issue. Even though you are expert in programs, but I'm sure that most of us will maybe mistake, and coming up with this kind of smart. So here what's happening? Here you can say that first when I consider the withdraw, the money is being transferred to the attacker, and the balance is not to zero. Somehow it's going back again. So therefore going into the loop without setting the balance to zero. That's why one amount will go to the attacker. That's happening in the attack, and it has been happened in 2016. After that people examine the thing and find that okay, the real attack that could be very dangerous. Another thing that injection attack that people have told us. So here you can find that somehow if I am a miner, I have I can do some kind of transformation with the timestamp in the block, and accordingly I can check some kind of bad input which can influence this winning strategy. So it means that I can check some bad thing, and I can attack the critical part of the computation which is happening in software. So this way also I can get some kind of attack. So this is the thing where know that whenever you are getting
services over Ethereum, some kind of smart services, you must have paid some kind of Ether. So that is in the form of gas cost. So here, even this gas cost, it depends on what kind of operations you are performing in the smart contract. So it may happen that if we do some kind of optimization, but here we have mentioned that we have to reserve the semantics. So if we can reduce some kind of operation here, we can save a lot of gas cost. And attacker can take this opportunity to attack smart contracts, attack you also. This is another one where we are typing the variable, but whenever you are typing it as unsigned, here have certain range. Whenever you perform some operations, if it is going beyond the range, so it can round off to the another value which will give you some kind of wrong result. So even though you are expecting something in the code, but actually runtime is having something else which will lead to lot of real loss. So that's the year for underflow. Wait, so transaction is also a kind of attack where we know that between two transactions, there can be some kind of dependency, and miner is deciding which order to follow. So if miner, somehow deciding different order, that can lead to some kind of financial loss to the users. And also some kind of attack that has happened, very multi-sig wallet hack. So here the actual library, wallet library is being hacked, is being taken, the control is being taken by the attacker, and somehow lot of users' money was old. Well, not only the security vulnerabilities, but also it suffers from some kind of safety issues. And these are few of them, for example, vision-wise low, for example, array out of bound. So you might have experiences of things when you do some kind of compilation. So all of them can happen and can be taken care of by the compiler. So we have to take care of this, and formal method is the only one which can guarantee some kind of complete correctness of your system. So as previous speakers, Dr. Kunal, they have mentioned about this need of verification. I'm just going to highlight few of them. So here as the vulnerability, as we are proceeding, so we can find that a lot of smart contracts are deployed, and therefore the vulnerabilities also increasing day by day. So now, if we look at the literature, we can find a lot of, more than 130, formal analysis and verifications are already done on the smart contract. So they include some kind of model checking, theorem prover, program verification, symbolic execution, runtime verifications, all of them. And I'm not going in detail of the existing thing, but I'm now highlighting what we are doing at IIT Patna. So here the takeaway is that all the tools, they are not complete. They cannot cover all the vulnerabilities. So it is observed that Mythil, even it is performing better, so it can detect only 27% of the vulnerability. Even we combine multiple tools, we can achieve up to 42%. So formal methods are very costly solution. So therefore it is the matter of finding some kind of trade-off between precision as well as computation cost. Well, so we observed some kind of, research gap there. For example, lack of theoretical formalism, lack of abstraction, lack of semantics formalism, lack of verifications, all those things. And this is the DST project we are executing, where we are planning to, build some kind of tool chain, formal method tool chain, which will incorporate formal analysis, formal verification, and also the most important thing is that we are trying to make it language independent. So even though we can use any kind of language, it may be Solidity, it may be Go language, it may be JavaScript, whatever, but the tool can be applied all over the smart contracts. But the most important thing is that the very challenging thing is the identifying some kind of semantics and applying the most challenging formal methods techniques. That is the abstract interpretation theory. We are also looking at that point. Here is a tool that we have built. I'm not going in detail of that. So here you can find that we are building that tool chain where you can find that given these smart contracts, we can get some kind of program optimization, program transformation, but here semantics will be preserved. At the same time, we have different kinds of intermediate representation, including CFG. Also, we are looking at object of representation that will make it language independent. So these are the things we are currently developing. I hope that within a couple of years, maybe 1 or 2 years, we'll be able to make it publicly available so that researchers all over the world can use it. So the most, open source code for, ONT is the most prominent formal analysis tool that is available publicly, and people all over the world contributing to improve this one. So we are also, looking towards that direction. So I'm not going in detail of that. Whatever you can see that whatever tool we are building here, it's not, just an algorithm. A lot of mathematics are there behind, and we are going to prove that whatever algorithm we have proposed, this is completely correct. So here we have defined the syntax of the Solidity code. We have defined the states of the Solidity code. We have defined the semantics of the Solidity code, and all are mathematical. I'm not going in detail of them. And finally, whatever, semantics rules are defined, and using that mathematical thing, we have proved that whatever algorithms we have proposed, whatever system we have proposed, they are completely correct. They will not fail during runtime. Whatever specification we have, they are fulfilling all this specification. So these are, some kind of intermediate representation code generation. So I'm not going in detail of them, but you can understand a lot of complex things are there. This is another way of thinking that we are looking at. So given a program, we can create some kind of, control flow graph, and by following some kind of symbolic execution, we can input the program in a logical form, and finally we can use some kind of theory prover, for example, Microsoft Z3, through which we can check the validity of that verification condition, and through which we can prove that the program, the smart contract, is working correctly. So another way is that Linux Foundation also introduced this kind of publisher-subscriber-based interoperability solution for blockchain. We have also, that modeled that, and we have also verified some kind of properties. Those properties we have written in terms of temporal logic, and we also find some kind of safety issues. I'm not detailing all of them, but offline we can take it. Here also we are trying to generate that logical encoding of the program in a different way. The verification condition, it can be based on symbolic execution, it can be based on conditional normal form, it can be based on that weakest precondition based thing. I'm not going in detail of them, just highlighting whatever we are doing. So having a loop is the most promising challenge in our program analysis and verification. So therefore we have to go for some kind of invariant generation. So there also we are contributing, and we are trying to overcome the two existing solutions, Incon and Incon Plus. We are coming up some kind of solutions that will improve over them. Not only that, we are also looking at, on Ethereum network, a lot of transactions happening. There are a lot of fissures, a lot of phishing attacks happening. So therefore, just identifying, analyzing the behavior of different users, the transactions, we can identify who are the features, who are not the features. We are applying machine learning, deep learning techniques to detect that thing. And recently also we have, we are moving forward towards metaverse, where a lot of transactions happening and blockchain support is inevitable over there. So we have already collected a large chunk of data of that decentral land, and we are applying machine learning, deep learning techniques over it to identify several kinds of, maybe predictions or security concerns also, probably. Well, so with NIC partner, we are also looking at, ABDM, Ayushman Bharat Digital Mission. That is the flagship project by Government of India, and where you can have some kind of Aadhaar number and you can avail all the health services. So this Ayushman Bharat Digital Mission providing digital health infrastructure for the country, and they have this stacked, layered architecture, but they don't have blockchain support. So we are introducing blockchain support. We have proof of concepts available now. We are trying to reach out Government of India. Let's see if whatever extent we can go with that. The main target is that for whenever we are sharing our health data, the log should be immutable, tamper-proof, and everything should be accountable. So that's our main purpose. Not only that, we are also building some kind of federated learning platform on top of that. We have different kinds of hospital groups. For example, Fortis, Apollo, Ruban, there are several other groups, and they do not want to share their data, medical data, with each other. So therefore, the federated learning can be the only way keeping the data privacy preserved. Right? So here they will do some kind of local training, and whatever parameters they will get, I mean learning parameters, they will share with each other, and eventually they will form some kind of global modeling. But here, many kinds of attack can be possible because all the stakeholders who are participating in this federated learning, they are not trustful. They can do some kind of poisoning attack, they can do some kind of lazy attack, so blockchain would help in this case. Through blockchain, we can introduce some kind of reputation system through which we can also define that who can be the attacker, whose model we can consider for the future work or something. So we have already the thing available, and the most important thing is that there are a lot of blockchain-based, even without blockchain-based federated learning platform, but experimentation with those things, benchmarking those things, it's very difficult. We are making some kind of simulation model where we can provide some kind of job profile, what kind of machine learning we apply, what kind of deep learning we apply locally, how many nodes will be there, how they will communicate with each other, everything will be provided in job config, and automatically the simulation network will simulate the whole infrastructure, will provide some kind of federated learning result. So that is the best thing that we are achieving now, and almost done. Paper writing is happening now. So highlight of my lab, I mean planner lab, programming language and robotics lab. So here we are looking at formal methods. So initially I have applied on database management systems, but we are looking forward to blockchains. Here also not only formal methods, but also we are looking for different kinds of applications, decentralized applications, and also we are integrating machine learning with blockchains. And I think I'm on time. So that's all. Thank you so much. So we can take the questions offline.
Thank you, sir. I would like to call upon Ms. Deja S. Ma'am, Associate Director, C-DAC Trivandrum, to kindly present a token of gratitude to Dr. Raju Halder, sir. I feel privileged to introduce our next speaker, Ms. Deja S. Ma'am. Ms. Deja S. Ma'am, Scientist F and Associate Director at C-DAC Trivandrum, is a cyber forensics expert with 23 years of experience in the domain. She holds a BTech degree in Computer Science and Engineering and an MTech degree in Software Systems with a specialization in Network Security. Currently, she is leading the Cyber Forensics Research and Development R&D activities of C-DAC Trivandrum, where she is also the Nodal Information Security Officer. She has prepared the Cyber Forensics R&D Roadmap of India, which was unveiled by the Ministry of Electronics and Information Technology, MeitY, recently. Her key achievements in the cyber forensics area include the development of more than 10 indigenous cyber forensic tools. More than 3,500 copies of these tools have been deployed to various law enforcement agencies across the country, including CBI, NIA, IB, State Police, etc. Various investigative agencies in India have taken her technical support in cyber crime investigations of crucial cases reported in India. She has 30 international research publications to her credit with 120 commendable citations. We welcome you, ma'am. I would like to invite Ms. Sonali, ma'am, Scientist E, C-DAC, Kolkata, to kindly welcome her.
Good afternoon all. since we are running out of time, I will try to conclude in 10 minutes. I would like to start with a quote. A hero is someone who has given his or her life to something bigger than oneself. So try to be a hero or heroine. So the agenda is like this. I'll just move through some of the reported cyber crimes in India. Then we will see what is the definition of cyber forensics. Then C-DAC cyber forensics initiatives and the tools in Make in India products developed by C-DAC. Then new areas of cyber forensics that are included in the cyber forensics R&D roadmap of the country. So these are some of the statistics. About 5,000 cybercrime complaints are registered in our portal, the NCRP portal, National Crime Reporting Portal, every day. And in that, 77% are online financial crimes and 12% are online social media crimes. What you can do, some financial frauds happen to you, you reveal OTP and some crimes happen. What you can do immediately? Somebody? You have to call the toll-free number? Which is that toll-free number? 1930. We have to immediately call on 1930. Within 3 or 4 hours, they can do something. You will get back your money also in case of financial crimes. Okay, so some of the news reports, OTP fraud happens, OTP reveal. Do you reveal OTP? If somebody calls you telling that I am from bank, I am a bank official, please tell me your OTP, otherwise your account will be blocked and you won't be able to do any of the transaction for the next 2 days. Don't reveal OTPs. Then ransomware attack that happened at AIMS. What happened? What was the impact? 1.3 terabytes of data was encrypted and 3 crore patients record leaked. And it was initiated by an email, Proton email ID generated from China and Hong Kong. So, since it is a ransomware attack, no traces are there in the non-volatile media. The traces will be only available in the volatile media. Challenging situations. And some fraud online complaint link. You are receiving an SMS saying that you have to click on this link to change your password immediately. If you click on the link asks for username and password of the banking transaction, bank transfer, or some other important information, including OTP. Then IoT device attack. IoT forensics or IoT systems are very new, but it's already reported in our country. This attack happened, it's reported in Hyderabad. Ransomware attack, some other ransomware attack happened at Tata plant. Then cryptocurrency scam. There are tools available for cryptocurrency forensics, but it's for the other cryptocurrencies. There is no tool available for the forensics analysis of Indian cryptocurrencies. Then the technology. As we are getting the emerging technologies, or we are privileged to get the new technologies, new type of cyber crimes are also being reported. So these are the cyber crimes. It can be against you, person, it can be against your organization, and also it can be sometimes against the country. And cyber warfare and cyber terrorism are against country. AIMS attack, can you consider it as a cyber warfare or cyber terrorism? Because it is against the country? Yes, AIMS attack, it's cyber warfare and cyber terrorism. Then we have IT Act and IPC. And if we submit a report, if we submit a evidence before the court of law, court needs evidence. But the evidence should be in a way that is admissible to the court of law. So, cyber forensics, the definition is this. It's a unique process of identifying, extracting, preserving and analyzing and presenting digital evidence in a manner that is acceptable to the court of law. So, never mishandle the evidence. Suppose you are getting a lot of material evidence, digital material evidence from the scene of crime. You are getting pen drives, you are getting loose SIM cards, you are getting lot many other digital devices. Handle it with care, otherwise it will get tampered. Never work on the original evidence. Suppose a machine is in the running mode at the scene of crime. Never work on that. You may get some evidence, but that may not be acceptable to the court of law because you tampered the system. The suspect can claim that I worked this machine only up to this July 1st, 2023. But there are files that get modified after that particular date, in August, in other months also. So it's not created by me. It's by somebody else. They can claim like that. Use proper solutions or tools. Cyber-forensic solutions or tools. Never trust the suspect operating system. If you are working for the evidence extraction, if you are working in the suspect machine, means you are tampering it. Never trust that suspect operating system. Then document everything. Document each and everything you are doing in the suspect machine. Suppose in some cases, like forensics you need to do, you need to capture the physical memory of the system. Then you are using the suspect operating system. So you should be careful in documenting everything. I am using C-DAC, this tool for the extraction of physical memory, for the dumping of physical memory. So it may tamper little bit the evidence available, but I am using it. You have to document everything you are doing in the scene of crime. So these are the different cyberforensic steps. First is identification, seizure, acquisition, authentication, analysis, presentation and preservation. What is identification? Identification means just you are identifying all the digital devices from the scene of crime. It can be desktop, laptop, servers, mobile phones, remote machines, handheld devices. So you have to take photographs, some non-digital devices, some paper printouts may be available. Later you can prove that this is taken by some other printers, no, the printer that is available inside the suspect room or at the scene of crime. That may be a crucial evidence at a later point of time. So the process of capturing the suspect computer or storage media for evidence collection is the seizure. In seizure, the important step is hashing. So we have to, have you heard about hashing? Hashing is considering the whole content, whole distinct content available in the storage media and converting it into a unique string, unique byte string. So this is it reversible or irreversible? Hash value, it is irreversible, but it's a unique value. Even if we change a single bit of the data, the string content, the hash value result, the next hash value will be totally different. So with the hash value only we can prove that we analyze the original evidence. In most of the cases, suspect can later claim that, oh, somebody else tampered my evidence. In that case, what the investigating officers can do, they can again take the hash value of the original hard disk, original storage media, and prove that initially the report is submitted to suspect, the same hash value we are having right now also. If it is different, they can escape easily. Okay, that's it, hashing. Then third process, acquisition. Acquisition is taking the bitstream content, entire bitstream content of the storage media to a destination hard disk, to a file. So the entire content of the hard disk of the suspect is now available as a file inside another destination hard disk. This destination hard disk or this bitstream file will be analyzed and the original hard disk will be preserved. We now work on the original hard disk. Instead, we will work on a copy of the bitstream content of the suspect. So that is available after this acquisition process in a file. That file is available in a higher capacity hard disk. So this is the input to the analysis tools. Before that, we will do authentication. Authentication is verifying that the file that is inside the destination media is having the same value as the original hard disk. The original hard disk is having this hash value. The copy we have taken after the acquisition is also having the same value. So we can start what process? Analysis. Analysis means we are reconstructing all the data, all the files and folders from the bitstream content that is available inside the file, inside the hard disk. So we will be getting deleted file also. We will be getting partially overwritten file also. We will be getting some information about overwritten file also. How is it possible? It's completely overwritten. How is it possible to recover the overwritten data? No, we are not deleting the overwritten data, but we may get some metadata of this particular file. The file is deleted, the data packet is completely deleted, but the name is available, the size is available, the timestamps are available, the type of the file is available, the extension of the file is available. So sometimes it may be very crucial in proving the case. So next is presentation, presenting the report to the court in a valid manner. What are the tools used, which version used? Preservation means we have to preserve it. The suspect or the victim can reopen the case later, at a later point of time. We need to reopen the case, so we need to preserve it. So we have live forensics also. Whatever I explained is related to offline forensics only. So whenever the system is on state, in the running mode means nowadays we have to connect the physical memory, volatile memory and do the analysis. Why? Nowadays most of the crimes are initiated by malwares. And these malwares are very interesting. Memory resistant malware, ransomware, fileless malware. There won't be any evidence available inside the non-volatile media. Hard disk. Other non-volatile media won't be having any traces related to this type of memory resistant malware. The resides only from the internet or some other USB or somewhere. It will get infected into the suspect machine and there won't be any traces inside the non-volatile media. So it's a must. We should do the live forensics in case of a running machine. If the system is in the running mode at the scene of crime means we have to collect the volatile media and we have to analyze that. We may get traces of keys, even the encrypted content. The file is encrypted inside the hard disk, but it will be in the raw form inside the RAM. The file is protected with a BitLocker key. That BitLocker key is available in raw form in the physical memory. So I am coming to this. My focus is to explain the features available or explain the Make in India products developed by C-DAC. I am directly moving to that. So we are mainly doing the R&D in cyber forensics and also we are doing the cybercrime analysis. We are providing basic and advanced cyber forensics training and also we are actively doing the setting up of cyber forensics labs and we are commercially deploying our Make in India cyber forensics tools. So these are the various projects we have completed under my team. Starting from 2002 onwards, we have working in the R&D areas of cyber forensics and we have so far completed 9,900 projects successfully and the last project completed in 2022. These are the various tools. We have tools in disk forensics, live forensics, CDR, IPDR log analysis, internet forensics, mobile forensics, network forensics, multimedia forensics, and we have an all-in-one solution also. All the solutions are available, all the software solutions are installed in a laptop that is embedded into a field kit and also the hardware imaging tool, the true imager. So if you bring this toolkit to the scene of crime means you can do the entire thing. You can seize the hard disk, you can acquire the image of the hard disk and you can analyze it using the software tools that is pre-installed in the laptop. So the entire thing can be done, even the report printout can be taken. So these are our existing lines, mostly investigating agencies and law enforcement agencies. And to academy also we have deployed our tools and for private agencies for various purposes. And these are the different cyber forensics labs commissioned by us, 36 labs across the country. So we analyzed major cases in various areas like financial crimes, anti-national crimes, mobile crimes, etc. Then these are the tools. Cybercheck is our flagship product. It is a disk forensics tool. The tool is able to recover the deleted file from the bitstream image and also all the files and folders. It's having so many analysis features like keyword searching, timeline analysis, partition recovery, format recovery, all the features, anti-forensics detection, report generation. Then mobile check is similar mobile forensic solution. Then Arctic CDR analyzer. What is CDR? Have you heard of CDR? Every incoming call or outgoing call of your phone is recorded by mobile service provider. So the police or investigating agencies, the first step of in case of a suspect, if I am doing a crime and I am the suspect in that particular crime. So the police must first collect the mobile data, my CDR, call data record from the my mobile service providers. If it is BSNL, they will collect it from the BSNL. So they will examine it, whether I have any connection with that terrorist group, whether I have any indirect connection with the terrorist group. I am not directly connecting that crime group. I am connecting to this person is calling A, is calling B, and is communicating with the A is communicating with B, B only communicating to that terrorist group or that illegal activity, that particular group. So what happens? The then that understood to be that indirect calling also the tool is able to recover. So many analysis features, even missed calls, they are recorded by the mobile service providers. Then if this is a large forensic tool, the tool is able to retrieve the physical memory and even the running process, it can be reconstructed using the NDF. Suppose you are running a cluster software, Cyberspace, you purchased Cyberspace, our flagship product from us, and you are executing it. Some malware code gets injected into this Cyberspace, code injection happens. So when we reconstruct Cyberspace AEC from the physical memory dump we have taken, it may contain some suspicious APIs because of that code injection. Like get us in key. Get us in key. Have you heard about that API? It's for taking the keystroke. Keystrokes are recorded. Keystrokes are recorded into and copied into a file. So when this notepad file or when this text file, .txt, and the write of the keylogger. So when this file becomes some 36 KB, it will be sent to my mail ID, the C-DAC. So the keylogger I have written like that. So the Cyberspace, some code injection happened and the API key is able to record all the new keystrokes and all the keystrokes of you will be recorded and I will get your password also, your username also. Then NSA, network section analyzer, SIM extractor, SIM card acquisition analysis, web investigator, just for identifying the browser habits of the suspect. Photo example, it's a new tool. It's for the image and video forensics, basically image forensics. So many cases, examples I can give because of the short of time. I'm just moving to the next slide. True image, this is a hardware imaging tool and it is able to image the bitstream content from the suspect hard disk. Then true travel, that is a complete forensics toolkit available. The entire thing we can do. Then CCF lab with the C-DAC department. We have a hardware lab. These are the new areas. IoT forensics, multimedia forensics, fintech forensics, etc. Then this is our currently running project. We are entering into new areas like fintech, IoT forensics, advanced data analytics, etc. in the current project. Then about the cyber forensics roadmap of the country. So in what area our country needs research? Is it necessary to initiate IoT forensics in our country? So all these, what are the gaps in foreign tools? Why it is not fitted in the Indian context? What are the gaps in making Indian products available in India? So all these will be addressed in the cyber forensics roadmap. These are the areas identified for cyber forensics roadmap of India. Internet forensics. Internet forensics means so many sub-areas of the social media forensics. It can be some material detection, the crimes against women, the dark web forensics, then multimedia forensics, image forensics, photo document forensics, video forensics, audio forensics, malware forensics. Malware, mainly ransomware forensics, any type of malware, device hardware forensics, can be any type of devices, vehicle. Inside the vehicle, so many hardware devices are available, SCADA, any hardware, GPS devices, critical infrastructure, any critical infrastructure areas like healthcare, transport area, power sector, fintech forensics, ATM frauds, online frauds, other UPI-based payment frauds, blockchain forensics, it can be cryptocurrency forensics, then any system that works with the blockchain technology, cloud forensics, you may be aware, cryptanalysis. What is cryptanalysis? Nowadays, we will be able to collect the data from some hardware devices, IoT devices, but the data is in their own proprietary format, no use. It's encoded or encrypted with their own algorithm, proprietary algorithm. So we need to decode or decrypt the data using our own methodologies. Then the future crimes expected are anticipated are agent-based attack. A good agent now become bad agent and behaving in a bad way, initiating some attacks. Attacks on AI system or attack by AI system. After relearning AI system is working indirectly or illegally. Quantum forensics means forensics on quantum-based system. Virtual world forensics. It can be forensics in metaverse, forensics in augmented reality virtual reality systems, then unveiled cyberforensics roadmap. This is the first draft. It was unveiled by MIT in November. Second draft, it was unveiled at the C-DAC Kolkata. Then the readable version is available in this link. You can have a look into it, and any areas are missing means you can report it to MIT. It will be included in the final roadmap. So this is my final slide and the final slide of the whole 2-day program. What C-DAC offers to you. So MOU to collaborate with your organization, your academic institution, your R&D organization, or your private company or startup. Training in basic and advanced forensics. Then free evaluation. We are providing free evaluation version and free demos of our tools, all our tools. Setting up a cyber forensics lab. Suppose your academic institution wants to set up a new lab means we are offering that. Extend technical support in cybercrime investigation. That also we are doing. And also we are accepting your valuable inputs for revising the cyber forensics of India. That's all. Thank you. The question I will answer offline, or you can even conduct an online meeting with me. Okay. My mail ID is aditya@c-dac.in. You can send a mail. Thank you.
I request Dr. Kunal Abhishek sir to kindly come and present a token of gratitude to Ms. Peter Islam. Thank you, ma'am, for your insightful session. I request Dr. Kunal Abhishek sir, Scientist E and Head of the Department, Cybersecurity and Forensics Group, C-DAC Patna, to kindly present the vote of thanks. Our Honorable Senior Scientist G and Director, Shri Aditya Sinha sir ji, will be addressing the gathering.
So thank you very much. Dija was the first speaker arrived here in this beautiful city, and she was the last to speak. And I can really appreciate your presence. You know, 2 days you have waited to deliver your talk. Thank you very much. And it was very interesting session. And the kind of feedback what I received from various corners is amazing. Okay. In such a short durations and timeline, we are able to manage the host of experts from all across the countries, not only from this our own country, from other countries also we have received confirmations, and you have seen that we had 2-3 speakers from different places. I am very thankful to the MIT actually that to interest and show their trust on C-DAC Patna, being the smallest center, being the newest center, and to give them such a daunting task, such a huge, tough problem to sort it out, and timeline was given for 2 years. We are already going to complete 9 months, almost 9 months, and the deliverable which was given to us, we are aligned with that. Everything has been done beautifully, very intelligently. Things have been managed by the team of C-DAC Patna, led by Dr. Kunal Abhishek. Then we had other members like Neeraj, Gaurav, Asim. We had new members also joined in, Saket. So big team is there in Patna. They are now been trained not to take up any easy tasks. They are supposed to take up all the tough tasks. And that was kind of, it's not, we always, everybody wanted to have to take up easy going things. But when we had gone there, we didn't have privilege because all other players were there in the scenario. They are getting those kind of things. So we had to satisfy ourselves with the tough tasks, with the kind of, the hard problems we are supposed to work out. But these kind of things are only possible because we had very good connects. And I am very thankful to all the members, all the speakers, all the experts around the country to support us. That's very much important for us because the kind of knowledge which is required to handle such kind of projects may not be there with Patna in such a short period of time. Due to the support connected with the experts, we were able to understand those aspects. And that was one of the kind of the mission to connect with everybody that is there with C-DAC Patna. And such a short timeline, we are able to manage very good speakers from all across. I am thankful to Saxena sir, and he has always encouraged us. In fact, a couple of times I met him in my other places also, and my team, to take up this kind of task. And in future also, sir, I will just, it's commitment from our side. But whatever tough problem you try to give it to us, now we have started enjoying that. Okay? So, small problems will not entice us. We have to work on the tough problems. We have now very well connected with IIT Patna, our vicinity in IIT Patna. Other C-DAC centers, they had treated us a bacha kind of things and taught us that how to go ahead with that. And all the C-DAC centers, like Trivandrum is doing the things since last so many years, Hyderabad is doing the things, Mohali is doing the things. So all of them have supported us, extended their support hand to us, and all the heads of those centers have shown a great faith on the capabilities of C-DAC Patna, and we are actually able to present whatever has happened. 3 products what we have seen. 1 product we launched last year, and that was the kind of blessings from all the seniors, all the members, all the experts of this particular domain, and we are looking forward to have more and more such products coming in future. Target is at least 100 people in next year, by next December, work on only cyber security for C-DAC Patna. So that is our and that too, I don't want to like my team is very much this average is 30. Okay, I have to just rush with them to catch hold of the things. And young students are all here, so that is an opportunity for you also. So I am going to be 100, we are going to be 100 on cybersecurity domain next year by December. So opportunity, I think most of you are from the final year. Opportunities for you also to understand the things properly and make a place for this very, very valuable team. We'll name it further on, later on, we'll name it something great names to think of. But that is kind of the team which is going to develop, which can address every cyber security problem of the country. That is our vision, that is our mission also. Okay. So thank you, sir. Thank you, all of you. Lot of connections are there. Krishna was ex-C-DAC and working in as a high-profile experts in different work with a high-profile expert in different organizations. And he was a great help, great source of aspirations for us that where he has reached, I want everybody have to aspire for that. Similarly, we had a lot of good speakers. Yesterday we have seen from very background. They have done that. already one organization where we have working very closely called ISSETC, and fortunately a good friend is there heading that ISSETC also. So I'm very hopeful Rasmi is here, his team, our team is here. Very hopeful that we can also work together. And so looking forward to, and this is not something which we are wish to do that. This is necessary things we have to do that in order to have a trusted cyberspace in this country. And I'm looking forward to put up all the energy to achieve that. So now Kunal will give the this vote of thanks, and it's his vision and his ideas. I just have managed to support him. Okay, that is my thing. And that work has been done by my team, and just as a senior I am there to guide him. That is the only contribution I can have. I was able to make these particular things. So thank you very much. Good night.
Thank you, sir. Your words of encouragement are always an inspiration for us to strive for excellence with tireless enthusiasm, and we will do our best to work towards your vision. I request Dr. Kunal Abhishek, sir, Scientist E and Head of the Department, Cybersecurity and Forensics Group, C-DAC Patna, to kindly present the vote of thanks.
A very good morning, good afternoon, and it has been a great honor to be a part of this wonderful International Symposium on Security Engineering for Trusted Cyberspace 2024. On behalf of the C-DAC Patna and the MITI, Government of India, I would like to extend my heartfelt gratitude to all our distinguished guests. At the outset, I would like to thank Sri Bhuvnesh Kumar sir, IAS and Additional Secretary, MITI Government of India, who graced the occasion and inaugurated 2 solutions of C-DAC Patna, Ganga and Glen CI, along with a book titled Deciphering Tactics, Techniques and Procedure of Ransomwares 1989 to 2023, compiled by C-DAC Patna and my team. Sir has also unveiled the cryptography roadmap of India, which will direct future investments and efforts towards keeping the Indian cyberspace safe and secure. Thank you, sir. I take this opportunity to thank Ms. Tulika Pandey Madam, Scientist G and Group Coordinator, R&D in Cybersecurity and UIDAI, who has been instrumental throughout in organizing this event with the present agenda. Madam has been the lead for a security project, in fact, on ransomware, which has funded to C-DAC Patna for execution. The symposium is one of the key deliverables of this project, as said by Madam, to extend the knowledge dissemination to all. I hope that everybody has got benefited out of this symposium. So it was like that. And her words are always of encouragement to us and are the guiding force for us, and especially her views and efforts on securing Indian cyberspace in large are notable. Thank you, ma'am. I take this opportunity to thank Sri Jitendra Singh Gangwar sir, Additional Director General, Headquarters, Bihar Police, who graced this occasion with his presence and presented an informative address to us. Thank you, sir. I would also like to thank Dr. Abhay Kumar Singh, Honorable Vice Chancellor, Nalanda University, who graced this symposium with his presence. I would like to sincerely thank Dr. P.K. Saxena sir, PSA Fellow and former Director, SAG-DRDO, for accepting our invitation and graced this symposium with his presence and presented a very informative session to us. We have certainly noted many things and takeaways from your talk, sir. Thank you. I would also like to thank Major General Ravi Chaudhary sir, Vishish Seva Medal, and Scientist H. NTO, who graced this symposium with his presence and for his very insightful session on the static cybersecurity. It was truly a great opportunity to listen to you, sir. Thank you once again. Now I thank Commodore S. Mohammad K. sir, Nausela Medal, for gracing this occasion with his presence and a wonderful session that he offered to us. There were many takeaways from your talk, sir. Thank you. I take this opportunity to thank our esteemed speakers for their valuable time and presenting their very informative sessions to the participants. I would like to thank the speakers in particular, Commander Saswat Raya sir, Commander Surendra Sharma sir, Sri Anand Rajesh sir, Sri Pranab Prakash sir, Sri Balaji Venkatesh sir, Sri Krishna Pandey sir, and Ms. S. Dija madam. I would also like to thank our international speakers for their insightful sessions in this symposium, and in particular, I thank Dr. Anupam Chattopadhyay sir, Associate Professor NTU Singapore, and Sri Rami Tamam sir, cyber legal expert from Israel, for their valuable time offered to the symposium. I would also like this opportunity to extend my thanks to Professor Somnath Tripathi and Professor Raju Bhatta from IIT Patna, who graced this symposium with their insightful sessions. Thank you, sir. Now I would like to thank Mr. Adit Kumar Sinha, sir, our Director and Scientist G, and Director C-DAC Patna and Kolkata, for his all hard efforts in organizing this symposium in Rajgir, and his continuous efforts to look after all the arrangements which made this symposium in this present form. His contributions to this symposium and in other way is extremely inspiring to us. Thank you, sir. My sincere thanks to all the HODs of various departments and senior colleagues across C-DAC Patna and C-DAC other centers, as well as MIT, who are being the part of this wonderful event. I take this opportunity to thank C-DAC Patna team members who worked day and night to make this symposium a successful event. I would also like to thank all the lovely people who have supported this event in their own capacity to make this occasion a memorable one. Finally, I would like to thank all the participants and all of you present over here for making the time to be with us during the two-day international symposium and made this event a memorable one. Thank you one and all. Jai.
Thank you, sir. With this, we come to the end of the two-day International Symposium on Security Engineering for Trusted Cyberspace 2024. I hope all of us would use the knowledge gained through the expert sessions to contribute to India's progress. I have two important announcements to make before we break for lunch. We have arranged 3 vehicles for visiting Gorakatora Lake, the ruins of Nalanda Mahavihara, and the Vishwasami Stupa. Participants are requested to convey their single choice from among the 3 to the travel desk outside. Participants are also requested to collect their participation certificates from the registration desk. Thank you. Please rise for the national anthem. Jai Hind, Jai Bharat. You will please proceed for lunch. Thank you. I request all the C-DAC Patna team members and the speakers to kindly stay back for a group photograph. All the C-DAC team members. I request all members from C-DAC to kindly come on stage for a group photograph.